most things that prolong your well-being and that build solid structures of success into your life are about what you can do on a daily basis, if not, 5-day-a-week basis, not what you can pull off, just once or twice.
Welcome to the Proof Podcast, a space for science-based conversation exploring the health and longevity benefits that come with mastering nutrition, physical exercise, mindfulness, recovery, sleep, and alignment. Facts, nuance, and trustworthy recommendations, minus the hyperbole. Hello, my friends. Welcome back. Great to be here with you. I'm your host, Simon Hill. I'm a qualified physiotherapist and nutritionist with an undergraduate science degree and a master's in the science of human nutrition. In my career, I've worked with many people, including elite professional athletes, to improve their health, performance, and longevity. And I'm currently involved in research with a group of nutrition scientists in Australia looking at dietary patterns and mental health. Today I sit down with Andrew Huberman, PhD. Dr Huberman is a neuroscientist and tenured professor at Stanford University. He has made numerous significant contributions to the field of brain development, brain function, and neuroplasticity, which is the ability of our nervous system to rewire and learn new behaviours, skills, and cognitive functioning. In this conversation, which Dr. Huberman very generously invited me over to record at his home, we cover what the field of neuroscience is, why neuroscience is important, some of the greatest discoveries within neuroscience in the past 50 to 100 years, why you may want to push back your early morning coffee to over an hour or so after waking, how caffeine affects the nervous system, learning new information and the benefit of non-sleep deep rest, especially if you're having trouble sleeping, real-time tools to downshift after intense alertness, why exercising early in the day is a good idea, supplements and brain health, and plenty more. Before we get into this, I should say we recorded this in December a few months back. Andrew has since announced 2 live events he is doing in the States, one in Seattle on May 17th and one in Portland on May 18th. To get tickets or find out more about those, visit hubermanlab.com/tour. Okay, please do enjoy the episode, and I'll catch you on the other side. Andrew, thank you for doing this.
Oh, it's a pleasure. It's been a long time coming.
Yes, I'm glad that we were able to squeeze it in as well while I'm here in LA, and thank you so much for opening up your space here and making this happen.
Oh, my pleasure. I've been looking forward to learning from you, so I'm happy to dive in.
I'm not sure about that, but we'll see. There are many different ways that we could take this. Clearly, you have such a broad area of expertise, and I have a loose sort of outline of things that I'd like to cover, but if we abandon that, then so be it. And some of these things are things that you talk about quite regularly, focus and memory and learning, and how we can improve our ability to learn, which I think is really critical and something that is very important, and your work in that area is very instructive. And then how sleep and deep rest sort of plays into that, and light exposure and sauna. There's a whole heap that clearly we can explore. And I would refer people to your episode with Rich, because we probably won't go through your backstory. It's a very interesting story how you wound up in neuroscience. And I think you guys did a wonderful job covering that, along with a lot of other topics like addiction and such. So if you're wanting Andrew's backstory, then please do check out that episode. I thought maybe we start here with a very simple question. You seem to take science very seriously from the point of view that you want to inspire younger generations, kids, to pursue a career in science and become interested in this field and what it can help us as a species in terms of better navigating the world and better making better decisions. If a kid said, Dr. Huberman, I'm interested in science. What is neuroscience? What is a neuroscientist? And why is this area of science important?
Mm-hmm. Well, yes, my goal, I'm not big on mission statements. They always feel a little contrived to me, but I confess I have a specific purpose and mission in my professional life, which is to share the beauty and the utility of human biology. We are endowed with a large number of systems in our brain and body that allow us to do many things and that do many things for us. The heart, the lungs, the liver, the brain, etc. The nervous system is unique among those systems, however. And so I would answer that young person, whoever they may be, by saying that what unifies all the systems of the body, thinking, feeling, action, digestion, temperature regulation, metabolism, muscular force, muscular endurance, dreaming, waking, all of it is the nervous system. If we were to peel away every other feature of your brain and body, including the skeleton, and just leave your nervous system, it would look very much like you. I mean, it wouldn't look like you externally, but it would have your shape. The nervous system includes the brain proper, which is housed in the skull. The eyes are 2 bits of brain outside the cranial vault, and the spinal cord. And then there are all the connections with the so-called peripheral nervous system. So all the little wires that we call axons that go out and connect to the muscles and allow us to move our limbs. But all the organs of the body also send connections back up to the brain. People often hear about the vagus nerve. That's one particular route, but there are a lot of other routes from, for instance, the surface of the skin back into the spinal cord and up to the brain to inform us of touch and pain and of various sorts. So your nervous system is like this superhighway in both directions between brain and body back to brain that synchronizes the activities of all these organs so that they work ideally in some sort of coherent way. So I would tell this young person that neuroscientists are trying to understand what is the structure of the nervous system, what is the function. So when I say structure, I mean what's the parts list? What are the areas of the brain that are responsible for vision or hearing or memory? What are the cells involved? How are those cells organized? Even right down to their molecular bits and the genes they express. In the last 10 years or so, neuroscientists have also started to feel more comfortable trudging into territory that previously was seen as kind of peripheral to the main thrust of neuroscience. Things like, how does the immune system get activated by stress? I mean, most people don't know this, but stress doesn't inhibit your immune system. Stress activates your immune system. The adrenaline is liberated from your adrenal glands, which are right above your kidneys, because something stressful happens. Get into cold water and you liberate a lot of adrenaline into your body, and it has a protective role in keeping you from getting sick. So in the short term, stress actually protects you from illness of bacteria, viruses, and other sorts of bugs, if you will. In the long term, it's problematic. But if you think about it from just that one example, and what I would tell this person is, look, you have an immune system. It's a beautiful system, just a fascinating system that can deploy molecules and cells to gobble up invading things and combat things and develop antibodies. And it's an amazing system. But let's say some foreign virus or bacteria or even some foreign object like a splinter enters your body. How does your immune system know to attack it? Well, it's because the nervous system creates a set of signals. The nervous system directs the immune system, go combat this thing. Similarly, if you have an experience that's good, we always talk about bad experiences, threats and traumas and things. So let's talk about a good experience. You experience maybe a kid has a music recital, or they discover that they have an affinity or a joy in playing an instrument, the drums or the guitar or something. The nervous system marks that experience through the liberation of molecules in the brain and body, like adrenaline, like dopamine, so that there's an excitement and an anticipation of it the next time. So the nervous system really sits at the seat of all of our ways of functioning, and neuroscientists try and parse what those roles of the different cells and areas of the brain are and the body are. Neuroscientists fall into a huge number of categories, too many to get into in detail here. But some work on the cellular aspects of neuroscience, meaning individual neurons, some more on the kind of the circuit level, how these different neurons communicate, and then others on a more systems level, fMRI scanners and things of that sort. And then the last point I would make to this young person would be to say, we understand quite a lot about the structure and function of the nervous system, but there's still an immense amount of information to parse. And there are many, many hundreds of years of careers to look forward to in this area. And so if ever there were an area of biology where there are terrific mysteries to go solve, it's within the nervous system. And I would encourage them to learn about the nervous system through school, through podcasts, through readings. It's really, it's the one that captivated me. But I think that all biologists respect the nervous system, and neuroscientists respect the other systems too. But it is special. It's different. Our brain is different than other organs.
What are some of the kind of most amazing discoveries about the nervous system, say from the last 50 to 100 years? I'm assuming that technology and skills have come a long way in the field of neuroscience. Are there any particular like pieces of science that are, up there as very critical sort of milestones or discoveries?
Yes. And so at risk of giving an answer that's too long, I'll kind of hit these in bullet point form because I've never been accused of being concise. First of all, there's an enormous batch of textbook knowledge that is not just beautiful, but truly elegant, that describes the basic functions of how we sense, perceive, feel, remember, and behave. Okay, so much too much to go into all in one sweep. But for instance, work in the last 50 to 100 years, and mainly within the last 30 years, of which I've been very fortunate to be a participant. These aren't my discoveries, but I've been around to observe these discoveries in various labs. My lab has made minor contributions to some of these areas, but for instance, we understand how light is converted into electrical signals that give rise to perception of visual images, even the recognition of faces. We can point to specific areas in the brain based on the beautiful work of Nancy Kanwisher at MIT and say, face recognition happens here. And it's built up from a very elementary, literally blocks and lines and dots that are put into kind of a template for face recognition. And people who have what's called prosopagnosia, they can't actually recognize faces, but they know they are faces, but they can't recognize the specific face. So that's just a beautiful example from Nancy's work and from my scientific great-grandparents, David Hubel and Torsten Wiesel, of how you build up representations of the outside world. Because the brain is in here, the nervous system is internal to the body, and so it has no knowledge of the outside world except the flow of electrical signals coming in. So that I would say perception, and I just gave an example from vision, but we have excellent examples from touch system and hearing, et cetera. The other would be, we understand at a deep mechanistic level now how neurons work, how they fire. And when I say fire, neurons function by signaling each other electrically and chemically. That's the work of several Nobel Prizes, and very deservedly so. We understand how that happens. Can you
explain what sorry to interrupt. Can you explain what a neuron is by definition?
Yeah, sorry, and thanks for stopping me. And to clarify, a neuron is a nerve cell. So you have different organs, and you have liver cells, and you have lung cells, and you have skin cells, and you have hair cells, and you have neurons, which are nerve cells. And what makes neurons unique is that they are electrically active. There are other electrically active cells in the body, but they literally send millivolts of electricity down their wires, these things called axons, and dump chemicals into their local environment. And then those chemicals inspire the next neurons to either themselves fire electrical, what we call action potentials. They're sometimes called spikes, but electrical action potentials. Or certain neurons will release chemicals that inhibit or prevent the action of another neuron from firing. A really simple example would be, we have this capacity to make deliberate voluntary movement. So if you move your wrist closer to your shoulder, the bicep is flexing because you have what are called motor neurons that send a little wire down to the muscle, release acetylcholine, and the muscle fiber twitches, it contracts. And so you're doing that. As you're doing that, you are inhibiting the firing of the tricep, the muscle that moves the wrist away from the shoulder, by way of release of a little chemical called GABA. And that occurs within the spinal cord. So you have flexors and extensors that are activating and inhibiting one another. And that's the reflection of the nervous system. And there are many examples of this in different parts of the nervous system. Bitter and sweet, for instance, are antagonistic to one another. It goes on and on. So I think those are examples that we understand something about perception and how we perceive. The beautiful work of Eric Kandel at Columbia University and others showing that we understand a bit about how the firing of cells in this region we call the hippocampus. Should also mention John O'Keefe and others who figured out that we have neurons in an area of the brain called the hippocampus that encode memories. And while you sleep, those memories are replayed by literally the replay of the firing of neurons in the hippocampus recapitulates what you experienced that day. and locks down a memory, passes it off to some other brain areas. We understand something about that. And there are some other discoveries that are just kind of what I would call foundational discoveries. Like, for instance, the discovery of the molecule dopamine, this molecule that is involved in our sense of motivation, drive, and craving, and that it, in its depletion, is responsible for the diseases like Parkinson's, and in its excess are responsible for, in some ways, for diseases like schizophrenia and mania. So, I mean, if you look back at the last 100 years or 50 years, you say, okay, they discovered dopamine, they discovered how nerve cells work, they discovered the structure of the nervous system. I mean, that goes back a little bit further, but neuroimmune interactions that the nervous system can activate the immune system, amazing. For instance, sleep and dreaming has a particular structure of neuronal firing. I mean, even as I describe this, I've been doing this a very long time now. I was fortunate to get into neuroscience quite young. It's still boggles my mind. And when people say, oh, we don't know how the brain works, that's kind of a silly statement. I mean, there's a lot we need to know, but so much has been discovered that 50 years ago we knew very little about.
Yeah, it's wild to think about how many things are being done at the same time.
Well, right. And, and I think we can make some broad categorizations that make it, that simplify what is a immensely complex process. So we have this autonomic nervous system that's making sure that your heart is beating and that you're breathing and that your digestion is occurring in the background. You're not thinking about that. You have a voluntary motor system that you can do things if you choose or not do things if you try. And then you have this capacity to direct your attention, which is incredible. I mean, we have what's called interoception, which is our ability to bring our attention to our internal milieu. Think about your heartbeat or your breathing and, everything within the confines of your skin. But you can also simultaneously exterocept. You can view things in your outside environment and pay a lot of attention to something in your external environment. You can forget about yourself. So we have a dynamic regulation of our attention, and it's happening all the time while the autonomic nervous system is doing its thing and while you're walking down the street. So the nervous system is an incredibly efficient system for running multiple scripts at once. And they sometimes collide, right? I mean, if you're really stressed, your visual perception narrows, for instance. If you're very relaxed, your visual perception broadens. You get a much wider view of the world around you. So these systems interact, but they are capable of working as what we call in parallel. And I think I don't think I've ever talked about this on any podcast, including my own, but parallel pathways are the fundamental feature of the nervous system, that things are happening all at once, as you said, in parallel. And the nervous system's job is to make as many things automatic as possible once they are learned, so that you don't have to think about your breathing. And you don't have to think about whether or not that person walking down the street is someone you recognize or not. It's just almost instantaneous. In fact, when you walk down the street, you're making distinctions all the time. Is that a young person, an old person, woman, man, or whatever category you happen to bin people in? You're doing that reflexively as you're going down the street. You're not thinking about it. You're just doing that, and you're activating modules of how to react or how not to react. And that's an amazing thing. And with no disrespect to people that work on other organs of the body, but the nervous system to me it's so vast, and we're very blessed to have a sophisticated nervous system. All humans have a sophisticated nervous system. Some less sophisticated than others, some more sophisticated.
I want to zoom in on attention and focus, but before that, you mentioned that example with the bicep, and that gets me interested. If we think about like strength training, and clearly you do a bit of that.
A little bit, yeah.
From what I've read and in conversations I've had with people, the like traditional strength training, so not hypertrophy, I'm talking sort of low rep training that people do, strength athletes, that usually comes without real muscle growth.
Typically.
Yeah, typically. I mean, there's obviously some hypertrophy as well, but is most of that increase in strength, an adaptation within the nervous system? Is that what's happening?
Yes. There are other features as well. But the ability to generate more force over time, per unit time, is the reflection of the activity of these motor neurons that reside in the spinal cord. And we have two main motor systems So we have what are called the lower motor neurons. So when you're just walking around, you're not thinking about it. You're mainly in these patterns of your lower motor neurons are firing and engaging the limbs by making these muscles twitch, by releasing literally dumping acetylcholine onto them. And in the neuromuscular system, acetylcholine, at least in mammals, causes contraction of muscle fibers. We also have what are called upper motor neurons, which reside in our neocortex, the outer shell of the brain, and which allow us to make deliberate actions. And so they can direct specific lower motor neurons to engage or not engage. And this is how we learn and engage in deliberate movement. And so when somebody is able to generate a lot of force or getting stronger without the hypertrophy, a lot of that is learning how to engage upper motor neurons to fire lower motor neurons in the correct sequence. Because any skilled powerlifter, of which I'm not, will tell you that the sequence of neural activation is very important. You think of something basic like a deadlift, and it seems so simple, right? You just pick up a weight, proper form. But assuming proper form and picking up a weight, there are two ways you can do this, right? You can think about grounding your feet and then contracting the posterior chain from the calves and hamstrings and glutes and lower back up, or you can imagine doing it from the lower back and pulling all at once. There are a number of ways to engage the sequence of motor neuron firing, and skilled lifters know how to engage the sequence of firing to put them at the best strength advantage. Getting stronger involves more contractile ability of the nerve to fiber synapse, what we call the neuromuscular synapse. So literally more transmitter, more acetylcholine dumped onto the muscle fiber so it can contract. There are changes in the muscle as well, right? Even genetic changes in the muscle as well, based on repeated strength training. But then there's the ability to bring more activation of lower motor neurons, so you can bring more activation of muscle fibers. And there's some interesting little quirks about the powerlifting community. For instance, the use of smelling salts. Not something I recommend, it's very common. Smelling salts are mostly ammonias, they're poison. And so when they're inhaled, people feel very alert because there's an innate hardwired system of when you inhale things that are dangerous, your whole brain wakes up immediately. And olfaction, smell is one of the most primordial senses by which we determine if we are in a safe environment. I always say there's kind of three main categories of smells. There's sort of yum, meh, and yuck. And so, the yuck stuff is generally poisonous or dangerous or infectious. I mean, let's just call it what it is. If you see vomit on the street, you generally recoil, right? If you see something that you don't know, like this tea is actually quite tasty. I like it. And I'll smell it. It's like, okay, it's great, but it's not like delicious smelling tea. And then there's certain things or people that we happen to just smell and we're like, well, you just want to huff more of that, right? And so that system is leveraged by smelling salts. People get very alert. What does that alertness do? That adrenaline in the body enables an activation of muscles by shuttling of fuel, et cetera. But also the alertness allows the lifter to bring more engagement of the upper motor neurons to the lower motor neurons and thereby to contract more muscle fibers in principle. And I know that and forgive me because the gym rats out there are going to tell me, well, it's not more muscle fibers, contractile ability in the type 1, type 2 fibers. But I get that. And we're trying to keep this somewhat top level.
So short of inhaling a poisonous substance, which I assume over the long term is not going to lead to a desirable result.
Yeah, most of these smelling salts don't harm people if they don't bring it too close or use it too often. I don't recommend smelling salts unless people really know what they're doing. They're actually illegal as a performance enhancing tool in a lot of sports. There are things like caffeine. You're bringing more attentional engagement through the dopamine system, but mainly through the adenosine system and adrenaline. So adrenaline's an amazing molecule in the brain and body. So there's caffeine. These days, there's a lot of interest and use of, and I don't want to get people trying things or doing things that their doctor doesn't approve. So talk to your doctor and probably don't touch this stuff at all. But a lot of people are dabble in kind of low-level supplementation, over-the-counter supplementation to enhance things like dopamine and norepinephrine, like L-tyrosine, for instance. Other people are using things that are more robust, stimulants, outright stimulants. And then, now there's actually a culture, and I do not recommend this because it can cause other problems, but unless there's a clinical need, people are taking things like cabergoline, which is a dopamine agonist that shuts down prolactin, and it just makes people hyper-focused, mental clarity. People are really into modafinil, armodafinil these days. A lot of the college students and kids are taking Ritalin, Adderall, modafinil, armodafinil. It's big in the office worker community. All of that basically funnels into the same common mechanism, which is to increase the amount of adrenaline, which is also epinephrine, released from the adrenals and also within the brain, an area called locus ceruleus in the back of the brain. It's kind of a sprinkler system on the whole brain. And when you drink coffee or any form of caffeine, or you ingest any one of the compounds I mentioned, you dump a lot of noradrenaline or adrenaline into the brain. It's a wake up signal for the brain.
Do you build a tolerance to that? Like, what's the downside of that over the long term?
Huge. And listen, the reason these compounds exist is that there are clinical needs. There are legitimate cases of ADHD and people need these. And, people vary in their responses, but I will say people who have a predisposition for anxiety, bipolar, mania, or schizophrenia can trigger episodes. These drugs look a lot like cocaine and amphetamine chemically. The abuse and kind of addictive potential is huge because they work so well. They find that sweet spot for 4 to 8 hours that they're able to work on a minimum of sleep. So there's a potential for abuse there. It's always good to pick examples that might actually be more meaningful. There are often sexual side effects. The arousal arc of sexual excitement involves being predominantly parasympathetic, meaning very relaxed for arousal. I don't know the age listeners of this podcast, but this is biology. Orgasm and ejaculation are actually very meaning sympathetic, not sympathy, although presumably it is in some cases. The sympathetic nervous system is more about alertness and arousal. So orgasm and ejaculation in males, but orgasm in both males and females is controlled by the sympathetic nervous system, which is a stress system. So what happens when people will ingest stimulants is they will reside at a portion of the arousal arc where let's just be blunt about it, they very much want to have sex, but they can't. That can happen unless the dose, outside of a very narrow dose range. So people who use stimulants are often very wired and driven, but have challenges there. So then there's the crash, because anytime you have a big peak in dopamine, there's inevitably a trough that mirrors that peak.
So you can't have it all.
You can't have it all. And my colleague Anna Lemke at Stanford wrote a book, Dopamine Nation. She also was on Rich Roll's podcast about addiction and this playing pressure balance. It's not just about addiction to compounds like heroin, cocaine, amphetamine. Of course, it's that too. But for instance, anytime we have a peak experience, that peak experience can have a long tail on it, but there will always be a trough afterwards in which dopamine feels low and we feel kind of underwhelmed and kind of depressed. The typical mode of action is to take more of the compound or try and engage in more of the activity that brought that dopamine peak. However, the problem is with each subsequent engagement in that compound or that activity, you get a lower and lower peak, but the trough gets bigger and bigger. And this is how people drive themselves into addictions of different kinds, behavioral addictions and other kinds of addictions. And I'm not puritanical with respect to this. Like I take supplements. I'll occasionally do a pre-workout that I prefer to use something in the cholinergic system like alpha GPC or something like that. I don't react very well to L-tyrosine. I do drink caffeine, but I'm very conscious of, for instance, not doing too many workouts or work bouts, mental work bouts, where I'm doing caffeine, taking something to boost dopamine, listening to a lot of music, going into peak experiences like that, because there's a cost. And the cost is that you can't come back and do it every day. And I'm of the belief that most things that prolong your well-being and that build solid structures of success into your life are about what you can do on a daily basis, if not 5-day-a-week basis, not what you can pull off, just once or twice.
Talk to me a little more about coffee. Because this is obviously a very commonly consumed beverage.
Yeah.
One of the most commonly consumed beverages in the world. And you mentioned caffeine. I'm interested. I think from listening to you, you try and push back any caffeine consumption in the you try and avoid it, I should say, in the first sort of 60 to 90 minutes of the day. Can you kind of talk to the importance of that?
Yeah. So caffeine, and we could talk about coffee specifically, but caffeine generally, so whether or not it's from tea or from coffee or from, I'm a big yerba mate fan. I think you got the black, we're both drinking this. This is not my podcast sponsor, but someone from Peak Teas sent us this what is it? It's like a pure, I like these fermented teas, these purer teas.
It reminds me of China. I've had several trips.
Very smooth, not tannic. I really like it. Again, not a sponsor, not promoting them, but the tea's really nice. But it has caffeine. So what's caffeine doing? Caffeine is causing the liberation of adrenaline from your adrenals, these two little marble-sized glands above your kidneys. That tends to activate the so-called sympathetic nervous system, make you a little bit more prone to move, bring some alertness to your body, if you, so to speak. And then simultaneously, it's causing the release of norepinephrine and epinephrine from this little cluster of neurons called locus coeruleus that we talked about before. So the brain is being hosed with a little bit of epinephrine as we speak right now. In addition, it's triggering a dopamine increase, but not by triggering the release of dopamine directly. Caffeine increases the sensitivity of dopamine receptors. So whatever dopamine is floating around in your system and my system, the caffeine is amplifying that effect. Not necessarily by making it a longer effect, by making the intensity a little bit higher. The other thing that caffeine does, and this is perhaps the most important one, is that it effectively prevents the action of a molecule called adenosine. Adenosine is a molecule that builds up the longer that you are awake. And then when you sleep, adenosine gets pushed back down to a minimal level. Adenosine essentially is a readout of fatigue overall. So if we were to stay up for 2 days, adenosine levels would be very high. So in terms of a practical tool, I do try and restrict my caffeine intake, or at least most of it, to the early part of the day. I'll stop drinking caffeine usually around 3 or 4 p.m. I don't drink any high amount of caffeine after 4 p.m. and generally not coffee. But when you wake up in the morning, depending on how well and how long you slept, your levels of adenosine might be zeroed out and you feel really alert, or you might have a small amount of adenosine hanging around. If you drink caffeine right away, what happens is caffeine acts as what's called a competitive, let's just keep it simple. It essentially binds to the receptor that adenosine would normally occupy.
It's an antagonist.
It's an antagonist, but it's what we call a competitive agonist because it binds, so it's an agonist, but it outcompetes the adenosine, so the adenosine can't dock at those receptors. So that's great because you start to wake up. But then around 2 or 3 p.m., as that caffeine wears off, the adenosine that's still around binds to those receptors and you get the afternoon crash. So one way that you can avoid the afternoon crash, or at least offset quite a bit of it, is to wait 90 to 120 minutes after you wake up to ingest any caffeine.
And so adenosine lowers.
Adenosine will continue to be cleared from your system in the early part of the day. And there's now it appears to be what I think is an interesting effect of exercise early in the day, close to waking. So in the first 3 hours of waking will also help clear adenosine. Okay. So this is why
I want to flush this out of the system.
Yeah. And this is why I think, for me personally, the best time to work out for me would be late mid-morning. I'm a bit of a lazy bear in the morning. But what I find is every time I work out early in the day, I have more energy all day long. And I never know why that is. And it's because most likely it's because you liberate a bunch of dopamine and adrenaline from your system. So you get a long arc of activation and alertness. Plus you are eliminating whatever adenosine is there. And so you feel like you have a lot of energy throughout the day. So obviously if you train really, really hard and you deplete yourself, you're going to feel sleepy in the afternoon. This is another sort of tool type scientific factoid, which is that when you train very hard, whether or not it's endurance training or strength training or what have you training, you're directing a lot of oxygen and fuel utilization to the muscles and less goes to your brain. This is the brain fog that you feel in the afternoon or after a hard workout. So you have to learn how much you can work out, how long, how hard, so that you don't actually reduce your brain's ability to function. A lot of people think they have ADHD or brain fog. They're just training like a maniac early in the day, and then your body doesn't have different resources for brain and body.
I wonder if that has a cumulative effect on IQ.
Well,
the gym bros might not want to hear that.
Yeah, well, and it's interesting because there's this kind of, I feel comfortable talking about, there's this sort of culture in academia where people are really, I know a lot of very smart people. I'm blessed to be surrounded by a lot of smart people inside and outside of academia. But generally, in the academics I know are really into endurance sports. They run, they swim, they play tennis. It's rare that somebody goes to the gym with a specific interest in building muscle. That's not typically associated with the academic phenotype, although there are a few. I have some colleagues that one down at Baylor who's an exceptional neuroscientist. He's really into, for instance, Brazilian jiu-jitsu. I think times are changing now. I think people realize that at least what the science shows, that unless people get about 5 or 6 sets of reasonably hard work of resistance exercise per muscle group, that they're going to be losing muscle over the course of their lifespan. And so that resistance training is important for maintaining neuromuscular function and for maintaining function of the skeleton. The weight training sends a signal, believe it or not, from the bones. Weight-bearing or load-bearing exercises sends a hormonal signal called osteocalcin from the bones to the hippocampus to ensure the ongoing health of neurons in this area that controls memory. Beautiful work by Eric Kandel's lab, and others. Whereas if you're just gliding peacefully through the pool and doing your mile laps a day, you get the enhanced oxygenation of the brain. You get what we call glymphatic clearance, which is at night you get clearance of the debris out of the brain is enhanced by daily exercise, but you don't get these other systems. And that brings us back to this idea of what's the nervous system doing. An organism of any kind, us or an animal of any kind, it needs signals to tell the other organs of the body what they need to do. And so if you are forced, for instance, you force yourself to lift heavy objects or moderately heavy objects 3 or 4 times a week, your whole system of being able to engage muscles is maintained. I will say this, that people who engage in regular resistance exercise and cardiovascular exercise, you see them in their 70s, they're sharp, they're mentally sharp. Now, I did say both cardiovascular and resistance exercise. You see people who are just chronic runners or cyclers, they're always complaining about injuries, right? They look like they're going to dissolve into a puddle of tears if they trip on a curb. People who are very large and too large for their skeleton, you can see it, they have trouble breathing and their cardiovascular system isn't working. So the extremes aren't good, but the behaviors that we engage in send signals back to the other organs of the body how to react and behave. So I'm a big believer, based on the science I know, of getting 150 to 200 minutes or so of zone 2 cardio per week. Zone 2 meaning you could maintain, this, but you can maintain conversation, but the heart rate is up. And then doing resistance training, 3 to 4 times a week. And I think that creates a balance between the various systems that we're talking about. And I should mention that that's my preference, but that preference is based on what we know about from quality peer-reviewed scientific studies, not done by my lab, of what's taken to maintain the skeleton, to maintain the neuromuscular system, to maintain the cardiovascular system.
Mm-hmm. Yeah, I think more and more people are talking about that now, the risk of sarcopenia, losing muscle, and that leading to premature death. So or trip and falling. I mean, we all, I'm 46 now, so I don't think about this too much. But when you start to see your parents get into their mid to late 70s, and you start to notice some frailty. I'm lucky that my parents are in good health, but that one fall can really diminish their well-being because they can break bones really easily. Or I have colleagues and friends who talk to me about it, the hip replacement. I'm like, hip replacement? You're a young person. What are you talking about, hip replacement? Well, they rode the bike like a maniac for 25 years, but didn't do anything else. Maybe did a couple like push-ups or something like that. So I think you have to, you get what you deserve, frankly, when it comes to physical exercise and health. I realize people come into the world with different propensities and genetic backgrounds, but when it comes to how well you maintain your strength and your well-being, grip strength, for instance, is a very good predictor of cognitive ability in later age. Not because being strong necessarily makes your brain better, but because generally people who have better grip strength in later age have been doing other things to maintain that grip strength, and there's a systemic positive effect. So it's really simple when it comes down to it. I think that 150 to 200 minutes of zone 2 cardio plus 3 or 4 days of resistance training at 5 to 6 sets per muscle group to maintain, and they should be hard sets. You should have a hard time finishing the final repetitions, but and I'm sure there are other tools out there. The stretching thing is interesting. I've been looking a lot into stretching and flexibility. It's not clear that our mobility is as related to stretching as we once thought. And here, Kelly Starrett would be a better person to talk to about that. It's the Ready State, and he's really the expert on this. But where's he based?
He's in the Bay Area. He's in San Rafael. The Ready State is his thing. He wrote the book Supple Leopard. But a lot of ability to move limbs in a supple way, and to have a broad dynamic range of movement, or generate ballistic movements or endurance type training, and all the different types of movement. A lot of that depends on your ability to engage or relax the firing of neurons that control different muscles. So if you think about, this is an interesting example that Kelly told me about. For instance, most people can't do the splits. I certainly can't do the splits, but I can put a leg up on a table at a 90-degree angle, one leg at a time. Well, the reason you can't do both at the same time when you're just sitting on the floor completely supported is because it's a fear-based mechanism and a reflex where one set of neurons activated inhibits the other. And so a lot of learning to do the splits is not about becoming more flexible, but learning how to disengage those inhibitory mechanisms.
Isn't that interesting?
Right. You always think of the muscles and the tendons getting more bendy, but it's actually a neural mechanism. There are other aspects to it. I mean, you can make connective tissue more pliable, but the idea that you're becoming more flexible isn't really the case. Is all those mechanisms were already there. It's neural, and it's neural inhibition it's a letting go. Now, hopefully people won't be tearing any groin muscles and trying to just let go. That's a skill. I can't do it. So I think that we sort of gone down the path of exercise, but I find it really interesting that most of the signals from exercise that create positive effects on cardiovascular function, on brain function, those are all mediated through the nervous system. It's not mediated through some magical increase in some mystery molecule. It's that the nervous system is saying, hey, you need to pick up heavy objects 3-4 times a week, or what are heavy for one particular person, right? And generate 6 or 7 or 8 or 10 repetitions of that. The neurons in those upper motor neurons, therefore, stay healthy because they have to engage the lower motor neurons in order to generate grip strength and engage the posterior anterior chain in the right sequence. It shouldn't come as a surprise, but I think a lot of people are surprised by that. They think that the muscle part is a kind of a dumb mechanism, but there are these interactions between brain and body. I think when we think of somebody or people who are very focused on exercise, but don't seem as cognitively enhanced as they do physically enhanced, let's say, I think that's probably just where they're spending their time. And sometimes these people can be, quite smart. But yes, we have these kind of preconditioned reflexes.
Yeah. I want to talk about Ronda Rousey. Actually, I watched a documentary. I'm not sure if you're familiar with her. UFC.
I know who she is. Yeah. I don't know her, and I know that she was a judo champion before she was an MMA champion. I know very little.
I know very little as well. But you mentioned judo. But before I go there, just to tie off on that. I think some people listening might be questioning their coffee in bed now.
Well, it depends on how long you stay in bed. I mean, and listen, the 90 to 120 minutes, you can ratchet toward that. You can try and push it out 15 minutes, 20 minutes. It is important to hydrate early in the day too. Caffeine is very dehydrating. It causes for various reasons related to its effects on the kidneys. You start to excrete sodium and potassium and the electrolytes. And those, the action potential, the firing of neurons that we were talking about earlier, is mediated by the entry of sodium into the nerve cells. And to some extent, the exit of potassium. It's a coordinated dance there. You need electrolytes for your nerve cells to fire. So when you're dehydrated, you can't think as well. You can't function as well at the neuromuscular junction. So the first thing I do when I wake up is drink water. I mean, you should hydrate first thing in the morning. Obviously, you should use the bathroom too if you need to do that. But then push out that caffeine intake a little bit. And it's a little uncomfortable at first, but and some people don't experience an afternoon crash, or people that are going back for more caffeine in the afternoon, they often find that they can drop or halve the amount of caffeine that they're drinking in the afternoon, which then has a nice cascade on the sleep system and the ability to fall asleep.
Often I hear when coffee comes up, people talk about adrenal fatigue and pineal calcification. I'm not sure.
Okay.
Are these legitimate sort of phenomenons, or have you looked into those?
Yeah. So adrenal burnout is a myth. I'm not saying that burnout is a myth, by the way. Adrenal burnout is not a real thing. The adrenals don't burn out. Your adrenals are immensely powerful. They were designed to take you through famine and horrible experiences and challenges that could go on 3 lifetimes. There is something called adrenal insufficiency syndrome, which is a legitimate syndrome where the adrenals don't produce enough adrenaline or enough cortisol, because the adrenals have a multi-layers, and cortisol is released from one compartment and cells in one compartment and adrenaline from the other. You can create a system of, wired and tired in your brain and body that comes from excessive caffeine intake. I think it makes sense to not overindulge in caffeine. And over the years, I'll tell you a story very briefly. In graduate school, I became jaundiced. I So I went to the doctor and I took some urine and blood analysis, and they started talking to me about alcoholism. Now, I don't drink. I used to have a drink or two now and again, but they were convinced I was an alcoholic because my liver enzymes were elevated. Then we got around to a discussion about caffeine. It turned out that I was drinking anywhere from 3 to 4 grams of caffeine a day. A typical cup of coffee is maybe 200, 500 milligrams. You can kill yourself drinking too much caffeine. And I wasn't on my way to death, but I was drinking far too much caffeine. But I prided myself on long work hours back then, and it was really bad, I think. And it was hard to taper that back. Now I drink usually a cup or two of coffee early in the day. Yerba mate is my preferred source of caffeine. Some days I don't drink any coffee. So you can really overdo it. I don't think you're going to burn out your adrenals. I think you're going to be stressed too often. You're just burning up energy. And we hear about fuel energy in the body, something you know far more about than I do, the utilization of fuel energy. But neurons and our nervous system have a sort of what I would call neural energy, the ability to focus, the ability to stay engaged. That's based on the dopamine and the noradrenaline system. And if you are chronically in a state of go, 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 and I should mention that dopamine and adrenaline, when they are enriched in our body and they're released in our brain, we tend to focus on that exteroception, things outside the boundaries of our skin. It's all about what we don't have going on now or that we don't already possess that we need and want.
So they're motivating us.
They are motivating us, but that being in pursuit is fatiguing over time. Whereas there are other neuromodulators and neurotransmitters like serotonin, oxytocin, things related to the anandamide system that are more about feeling content with what we already have or what's in the confines of our skin. The beautiful place we happen to live in, the people that we happen to have, social connection, they tend to be very soothing. And, for better or for worse, a lot of our success in life professionally and our ability to obtain those relationships and those things come from being in pursuit. But you have to think of this as a seesaw that you need to be able to run back and forth on. You can't just be in full pursuit of things all the time. You have to learn how to turn that off. And so I guess the point is that with excessive intake of caffeine or stimulants of any kind, nicotine, caffeine, you're going to run into a problem where you'll feel lousy without it. You'll start to feel a little bit more depressed. And for people who have underlying issues with OCD or who have underlying anxiety, for people that tend to ruminate, for people that tend to have insomnia, it makes sense. You're just ingesting far too many stimulants.
Yeah, it's not going to be for everyone, at least not at a certain dose.
Right. You have to find the sweet spot. And I always say that when you haven't slept well is when you should drink less caffeine. When you've slept really well, you can get away with drinking more caffeine because you're more regulated. The autonomic nervous system is also like a seesaw. You have this, what we call sympathetic or alertness system, and then you have a parasympathetic nervous system. And they're controlled by different neurons and molecules in the body. But don't think about the seesaw as you. What's happening is you have the seesaw inside of you, and you're kind of running back and forth. Okay, it's like, get to the appointment and have the meeting, do the podcast. Okay, we're really lasered in. And then do you have the ability afterwards to adjust that seesaw back? When you're sleep deprived, the hinge on that seesaw becomes very loose. So it's sort of like, boom, you're just locked in. I got to go, 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 go. And then you're exhausted. Boom. And so when you haven't slept well, you can probably get away with drinking a little bit of caffeine, but your whole system is dysregulated. When you've slept really well, you can probably drink more caffeine and feel more in control of your mind and body. So it's a little counterintuitive. Yeah, exactly.
Where does the pineal gland come into this?
Yeah, I forgot to answer that. So the pineal is this little pea-sized gland for the aficionados out there. It sits right near the fourth ventricle in the middle back of the brain. It's a really interesting gland. It releases melatonin, which is a hormone that has many functions. One of its functions is to control the transition into sleep. It doesn't keep us asleep, but it makes us sleepy. Melatonin is profoundly inhibited or reduced by light. So much so that, let's say you get up in the middle of the night and you go to the bathroom and you flip on the lights and they are very, very bright, like hotel fluorescent lights. Your melatonin just plummeted to zero. Okay. Melatonin, as far as we know, the only source of melatonin in the brain and body is the pineal. And it's a really important hormone. It also controls the timing of puberty in interesting ways. In children, melatonin is chronically high. And that then when it adds upon entry to puberty, it becomes more cyclic, cycled. Melatonin comes from the pineal, and the pineal has around it some bony structures in which that there can be some calcification of the pineal with age. However, there are a lot of theories out there that, fluoride calcifies the pineal. Maybe it does. I don't know. Caffeine can calcify the pineal. Maybe. This is all done post-mortem cadaver type studies, looking post-mortem. But the real question is, does the calcification mean anything for the function of the pineal? And I'm not aware of any solid evidence that says the calcification actually prevents the pineal from releasing sufficient amounts of melatonin. That said, I think most people are probably ingesting more caffeine than they should, including me. And, and the relationship between things like fluoride and all that, a few years ago, I would have thought, well, that's just kind of crazy, like wacko, whatever. But, we're discovering now more and more that all these things like sunscreens, I remember hearing years ago, oh, there's stuff in sunscreen that will go into your brain. I remember someone telling me, like, you're crazy. What are you talking about? I'm a scientist. Turns out there are certain sunscreens that have molecules that can cross the blood-brain barrier, and you can find them in neurons like 10 years after people have used this sunscreen topically. So I've become not paranoid about this. I don't tend to use sunscreen.
Is there certain ingredients to look out for?
Yeah. So I'm probably going to get this wrong. So maybe one of the viewers can put the right answer, but I think the one of the molecules is something called triclosan.
Okay. We can update it in the show notes.
Yeah. And to those working in the triclosan industry, if it's not triclosan, I'm sorry. And if it is, please stop. No, I think there are a number of molecules that are in creams and perfumes and things that can go transdermal. Now, I don't put myself in the kind of really far category of, won't touch standard toothpaste and don't use standard soaps and whatever. But I also don't place myself into the category of, every chemical is fine for us.
Keep an open mind.
Keep an open mind. And I think, you could look at the work, if you wanted to go down this path. There's a really wonderful professor of integrative biology at UC Berkeley, Tyrone Hayes, who's looked at things that are in common water sources that affect the hormone system. And he looked at this stuff in alligators and frogs and in humans, that there are molecules that can really disrupt the estrogen and testosterone systems. And when that stuff first came out, people thought, this is really conspiracy theory type stuff. No, this is solid science. It's in the textbooks. If you look at the endocrine textbooks, some of which are sitting on the shelf behind me, you'll find Tyrone's work, and it's very, very solid. And it's led to some, but not enough changes in water treatment and what kind of things people can dump into water. So, these are real effects, and you can learn a bit about it by exploring those things. But in any event, I think that the calcification of the pineal is something that I don't tend to worry about. I do think a lot about sleep and what's good for sleep and what's not good for sleep, but I don't worry about my pineal being calcified.
Yeah, we'll definitely go into light exposure and sleep. Why does someone experience caffeine withdrawals when they stop having coffee?
Great question. Two main reasons. One is that caffeine, because of its effects on adenosine, and because of adenosine's relationship to the way that nerve cells connect to the vasculature, to blood vessels and capillaries, that when they stop drinking caffeine, they actually get changes in blood flow and they get headaches. And so you're either hyperperfusing the brain and head. And so there's a compartment in which between the brain and skull, sort of, I don't want to get too into details, called the meninges, and it's very heavily vascularized. Your brain is very heavily vascularized. And it's sort of tricky. For chronic caffeine users, the blood vessels actually dilate when people drink caffeine because they're caffeine adapted. For people that are not caffeine adapted and just have a cup of coffee and they never drink caffeine, the blood vessels constrict. And that's because of the way that adenosine and these systems tend to regulate themselves over time. So if you've been drinking a lot of caffeine and you stop, you can get pretty brutal caffeine headaches because of the changes in blood flow to your brain. And that takes a little bit of time. And generally tapering by mixing decaf with calf and then tapering off. Some people also find that they do much better drinking things like yerba mate tea. I'm a big fan of yerba mate. I don't have any relationship to the mate company. I am Argentine, half my family, but and just to mention, because you and your listeners will know, some of them will know this, that there are some claims that yerba mate can cause mouth cancers and things of that sort. Generally, you want to avoid the really smoky or toasted yerba mates. There's some pure leaf mates out there. There's some little organic farms that make them. I don't have any relationship to them, but there's one I found on Amazon. It's called Anna Park. I don't know who Anna is or where her park is, or if she's even a person. But that's a very clean, nice tasting mate, loose leaf mate. The ones that are really toasty or really smoked, they have a lot of preservatives in them.
Do you like the flavor, or is there something in it?
Yes, a couple reasons. One, that the caffeine is a little bit lower level than in coffee. I love the flavor as long as it's not the toasted ones. I don't like smoky anything. Smoke anything. It's just kind of doesn't work for me. The other reason is it has a lot of a compound called GLP-1, glucagon-like peptide 1. Glucagon-like peptide 1 is very interesting. It's in, I think it's approved now, but it was in clinical trials for the treatment of obesity and diabetes.
Suppresses appetite.
Suppresses appetite in a major way, and also leads to more lipolysis, especially under conditions of caloric deficit. So it's a kind of a fat burner, if you will. Of course, caloric deficit is required for net fat loss, et cetera. I don't want to get the calories in, calories out mafia after me. That already happened. You know, they
gotta be careful.
Yeah, they come after you with nothing, but they come after you nonetheless. And they're right. Calories in, calories out is kind of the foundational principle of weight loss, maintenance, or gain, regardless of food source. And there are small exceptions, but not meaningful ones. But glucagon-like peptide has an interesting story that's kind of fun. It actually was discovered in Gila monsters. I used to call them Gila monsters, but I was corrected. They're called Gila monsters. These poisonous, they probably have them in Australia because everything dangerous comes from down there, or everything down there seems dangerous.
Have you been to Australia?
I haven't. I love it. I'm obsessed because I love animals and strange animals. I can't wait to go back. I spent far too brief a time there. It's amazing. Love the people, love the place, love the food, love the 6-foot tall kangaroos on the side of the road. Yeah. It's paradise to me.
There's a lot of great wildlife.
Yeah.
Okay, so this animal.
So this animal doesn't eat very often, just like many snakes don't eat very often. But the Gila monster turns out to be the world heavyweight champion of not eating. And so this biologist, forgive me, I forget his name, tried to figure out how is it this animal can remain not hungry for so long because they have quite a high activity level compared to a lot of reptiles. And it turns out that they make extremely high levels of this glucagon-like peptide. He isolated it. He looked for it in other species. It turns out it's in humans too. And when we enter states of fasting, we secrete GLP-1. It's kind of a sustain energy and burn type molecule. And now it actually exists as a pharmaceutical agent, not surprisingly. It's going to be a big diet drug, diabetes drug. But yerba mate is enriched in GLP-1. I'm not trying to get particularly lean or anything, but I figure at my age, anything I can do to keep my metabolism, pointing in the right direction is good. And I happen to like the taste of mate.
Gila monster. Is that what it's called?
I think it's spelled Gila, so Gila monster.
Gila monster. I wonder if does it have like a really long lifespan, given it doesn't eat a lot?
We should ask David Sinclair.
Yeah, we should.
Yeah.
That's interesting.
Someone out there ought to know. I have to be careful not to go down these rabbit holes too deep, but I will say that one of the most beautiful set of stories in biology, should anyone interested in looking at that, a lot of what we know about the nervous system is based on the identification of toxins from different animals. Like, for instance, everything we talked about with neuromuscular junctions was studied using a molecule called alpha bungarotoxin, which comes from pit vipers. And so people actually used to milk pit vipers and then do studies in the lab. I wish I had been alive at the time when this kind of science was done. Or for instance, learning how nerve cells release chemicals like dopamine and acetylcholine. A lot of that was studied using a toxin called alpha-latrotoxin. Alpha-bungarotoxin from the pit viper blocks the receptors on the muscle side. That's how they paralyze their victims and then eat them. And so it was used to study the neuromuscular junction, whereas alpha-latrotoxin is what's made by black widow spiders, and it's a really diabolical molecule. When an animal or when something gets bitten by a black widow spider, the way that it dies is it forces liberation of all the neurotransmitter in the body all at once. So imagine you dump all your dopamine, all your acetylcholine, and then you're just this like frozen mess, and then it eats its thing. And the pufferfish makes curare and blocks action potentials. And so there's this beautiful and kind of sinister description of how these hunters in the wild were the molecules they make were exploited for the study of the nervous system. And in a very simple and frankly humane way, humane-ish, I could say, I'm guessing a few pit vipers died in the early days of this stuff. But then what would happen is once you know the sequence of that particular peptide or molecule, you just manufacture it in the lab. Now, these are very dangerous substances to use in laboratories. And these are the same substances that are the stuff of a lot of biological warfare. one, since you talk about food a lot on your podcast, botulism comes from canned goods, right? The botulinum spores or botulinum, it blocks nerve transmission, prevents nerve cells from releasing transmitter. And, years ago when Iraq was invaded and, there was this whole story about weapons of mass destruction or not, or however, what is true is that Saddam had botulinum spores, and it took tiny concentrations that can be used to wipe out a whole city.
Where from?
Where'd he get them?
Yeah.
I think they just grew them there.
Oh, they grew them.
They just grew them there.
Interesting.
So anyway, it's a bit of a divergence, but I think it ties back to some of the how the understanding of the basic function of the nervous system came about. A lot of that was from observing things in the animal kingdom. Conefish, for example. If you've ever been swimming in the Pacific, you worry about sharks quite a bit. The biggest danger to you out there, besides a stingray maybe, is that these little conefish, they will shoot this little tentacle up and like barb you if you're thinking you're a fish, because they're dumb little things. They just see a shadow, and they release what are called conotoxins that can kill you at picomolar concentration, which means a tiny, tiny concentration. So when I'm swimming out there, I worry about sharks.
But they're down here.
They're all over the Pacific coast. They tend to be at the deeper, abalone divers know to stay away from these things. But yeah, there are a lot of deadly.
Can I get through a wetsuit?
Oh yeah.
Gosh.
Yeah. Yeah. I actually took a cone snail injection when I was in the Caribbean years ago, but it was from a non-deadly type. But you don't hear about that many deaths from these kinds of things because most people aren't swimming out that far. But yeah, you're worried about sharks. You worry about sharks, but these conotoxins are a real thing.
Yeah. Coming back to that seesaw.
Yeah.
So if someone is sort of riding that adrenaline roller coaster, so to speak, but perhaps doesn't have the tools to switch off and bring themselves back down, after an intense discussion or something where they're highly focused, what are the tools that you like to speak to that people can kind of tap into to help bring that nervous system back down to balance?
Yeah.
Relative balance.
Yeah, I'm glad you asked that, because this is right in the wheelhouse of what my lab does, which is in addition to studying vision, we study stress, calm, and sleep, and how to access those states. And I think we're all familiar with the importance of meditation and good sleep and a number of other things to keep our nervous system regulated and functioning. But one thing that we've really been emphasizing in my lab is a study of what I call real-time tools. What can you do immediately after this podcast to downshift while you're driving back to wherever you're going? You're not going to meditate while you're driving. It can be meditative, but how do you downshift quickly? Let's say you're about to engage in something, you're feeling like you're just too sympathetically aroused, meaning you're just too alert. Well, there's a very simple tool that's based on really about 70 years of physiology, but I like to think that we've unearthed this for people recently, which is to do a double inhale, long exhale. It's called a physiological sigh. And the best way to do this would be to inhale deeply through your nose until you can't inhale anymore. And then take one more little inhale, a little sharp inhale, just try and sneak a little bit more air through your nose, and then exhale all the way. I'll demonstrate it and then I'll explain how it works. So it's okay.
So you really have to breathe right out.
Yes, you want to breathe it all out. So first of all, some basics of breathing and how it relates to heart rate. For reasons that I won't go into right now, when you inhale, your heart rate tends to speed up a little bit. When you exhale, your heart rate slows down. This has to do with the movement of the diaphragm, how much space is in the thoracic cavity, and a signal from the brain. The physicians and others will know this as respiratory sinus arrhythmia. There are also other ways that your heart rate can speed up and slow down, of course. But when you inhale, your heart rate speeds up a little bit more. When you exhale, it slows down a little bit more. Now, your lungs are incredible because they're these two big sacs of air. You bring in air down through the trachea, it goes to the lungs, and then that oxygen actually moves directly into the bloodstream. And so an inhale is an active process of bringing oxygen in, and then an exhale is generally a passive process. It can be done actively, but it's a passive process. And the exhale is where you offload carbon dioxide. And that ratio of oxygen and carbon dioxide is absolutely crucial. It's not that oxygen is good and carbon dioxide is bad. It's the ratio that's important. In general, in humans, the amount of oxygen in our bloodstream and brain is pretty constant. It varies, but under healthy conditions, it's pretty constant. But the amount of carbon dioxide varies tremendously. When you're holding your breath or when you get stressed, when you're too anxious or too alert, levels of carbon dioxide typically are higher than you want them to be. When you do this double inhale, something special happens. The lungs inflate, but your lungs are not just two big bags of air. They have hundreds of millions of little tiny sacs called alveoli of the lungs, and they have fluid on the inside. And when you get stressed or when you haven't breathed enough, those little sacs collapse, they deflate. But because they have fluid on the inside and there's surface tension, it's like trying to pull apart a balloon that has fluid in the middle. It won't open very easily. So you need a big inhale, and that second little sneaky inhale at the end
pops them open,
and then you can offload the carbon dioxide. You do this subconsciously about once every 5 minutes. You don't necessarily do the double inhale, but you take a big, deep about once every 5 minutes, and you even do it in sleep.
Is that your nervous system noticing that those, what did you call them again?
The alveoli.
Alveoli. That sounds like a ravioli.
Yeah.
They're closed over and that you need to fill them back up.
Yes. The way that your nervous system creates the trigger to do a physiological sigh or to breathe at all is by the buildup of carbon dioxide in the bloodstream. And you have some carbon dioxide sensing neurons in the brainstem. Jack Feldman at UCLA is the world expert on this. He discovered the two brain areas responsible for breathing, pre-Buttsinger complex, prefacial nucleus, if people want to look those up. And has done a lot of important work on physiological size, more than me, to be quite honest. Jack's really the heavy hitter there. So I think that when you do a physiological size spontaneously, it's because carbon dioxide was building up. There's this email apnea, they used to call it, when people are emailing, they're holding their breath and then they go,
I'm guilty of that.
We all are. We all are. So you can use physiological size to rapidly decompress. Just 1 to 3 of those, double inhale, exhale, double inhale, exhale, double inhale, exhale, and you will be calm. It's the fastest way that I'm aware of to calm down.
Is that good if you're having trouble falling asleep and you have 1,000 things running through your mind?
Yeah. So I would say for the ability to fall asleep, you need to calm your nervous system. So I would do a few of those. And then if you have trouble turning off thoughts, which is complicated thing, as you know, I suggest there's a zero cost app that was developed for Apple and Android by my colleague at Stanford, Dr. David Spiegel. I say Dr. David Spiegel because he is indeed a medical doctor. He's our associate chair of psychiatry. And what the Spiegel lab has developed is this app called Reveri, Reveri. Reveri.com has a self-hypnosis script that's been shown in clinical studies and a number of mechanistic studies that will allow people to turn off thinking and transition into sleep more easily. So you could use it if you're having trouble falling asleep, but best to use it once or 2 or 3 times a week to get better at decompressing. And you just can get better at sleeping through self-hypnosis. And there are neural mechanisms for this, learning to turn off some of the areas of the cortex involved in planning and action. So that's, but I think for most people, the physiological sides are a great way to say, okay, I'm feeling overstimulated. I want to calm down. Is the best way to just bring everything down a notch.
Cool. That's a good tool.
Hey friends, I hope you're enjoying this episode so far. A quick message from one of our sponsors who makes this show possible, and then we'll jump straight back into things. If you're familiar with my nutrition philosophy, you will know that I'm a huge believer in plant-rich diets being better for people and our planet. You'll also know that I frequently draw attention to what I describe as nutrients of focus. These are nutrients that science shows plant-based eaters, whether plant predominant or exclusive, can fall short in, which can leave you feeling run down, lacking energy, experiencing brain fog, and generally just not as vital as you'd like to be. For that reason, together with Emil, a plant-based health and wellness company, I formulated Essential 8. Essential 8 is your one-stop multi-nutrient, formulated with DHA, EPA, omega-3s from algae oil, vitamin B12, iodine, vitamin D3, iron, zinc, selenium, and calcium to perfectly complement your plant-rich diet. I personally take Essential 8 every morning with breakfast, just 2 capsules, much easier than supplementing with these 8 key nutrients individually. What's even more convenient is I have a monthly subscription, so it turns up automatically on my doorstep and I never miss a beat. To get yours, head to theproof.com/friends. That's theproof.com/friends, where you'll find a link to purchase Essential 8 that will get you an extra 5% off your first order on top of the significant subscription discount. There will also be a link to this in the show notes. Okay, back to the show.
If someone is, let's say, struggling to fall asleep and they do have all of those thoughts racing through their mind, I've heard you talk about yoga nidra, but am I right? Is that something that you would use more in the start of the day, or could you also use that at the end of the day?
Yeah, yoga nidra is, I think, my favorite tool of all in all of mental enhancement. Or yoga nidra literally means yoga sleep. These are free scripts on YouTube. The one I like, you could just, I have no relation to them, but you could put yoga nidra theta 30-minute. There's a theta rhythm one that I happen to like, but there are many others. You have to pick one where the voice guides you through a number of self-relaxation steps. And sometimes there's an intention or something of that sort. And it brings your brain and body into a state that's very similar to sleep, but not quite sleep. Yoga nidra done 1 to 3 times per week has an immensely powerful effect on teaching you how to deliberately turn off your thoughts. It's allowed me to work in, I think, a far more concentrated way than I would otherwise. It's used now in a lot of trauma release programs. People who are dealing with a lot of overwhelm will do yoga nidra for 30 minutes or 20 minutes, or sometimes even an hour a day. And there are a few studies, mainly out of Scandinavia, showing that 30 minutes of a yoga nidra script can reset levels of dopamine in the area of the brain called the basal ganglia, which is involved in planning and action and controlling reflexive behaviors versus deliberate behaviors. It's a very powerful tool. You asked when to do it. I like to do it in the morning, right after I wake up, if I felt I haven't slept enough. And the reason for not sleeping enough could be because I couldn't fall back asleep. I'm ruminating. I have to get up and work that day. I come out of that yoga nidra always feeling as if I slept more than enough. It's really remarkable.
And how long do you do that for?
I do a 30-minute nidra.
Cool.
And then there are times when in the afternoon I'm feeling a little run down, and sometimes I'll take a 20-minute nap. The rule on naps, according to Dr. Matthew Walker, is naps should always be shorter than 90 minutes. So they could be 10 minutes or 20 minutes, but they should never interfere with your nighttime sleep. So if you can take a nap and still sleep at night, great. But if you take naps and that disrupts your nighttime sleep, then you shouldn't nap. Yoga nidra could be done in the afternoon instead of the morning. Or if I do wake up in the middle of the night and I'm really having a hard time falling back asleep, I'll do a yoga nidra as a replacement for sleep because it's the second best option. A lot of times I'll fall asleep during those nidras, which is great because I wanted to go to sleep. I love them. Or I use Reverie. I'll use that app. So I would say do it first thing in the morning or in the afternoon or any time of night, but it's not something you have to do every day. I think a lot of people think, oh, you have to do it every day. I mean, you're teaching your nervous system how to deliberately relax. Likewise with physiological sighs, if you do them regularly, you'll find that you have an easier time relaxing when you decide to do one spontaneously.
Mm-hmm. Do you do yoga nidra sitting down or lying down?
I lie down.
Okay.
On any surface. Yeah, I lie down. If I've done them in my car before, if I'm like, I hate commuting and I hate traffic. So sometimes if I'm feeling really tired, I'll just pull the car over, not on the side of the freeway, but I'll pull over into the neighborhood and I'll put the seat back so I'm not fully reclined, and I'll just listen to a nidra and come out of that. I feel great. I love nidra. I think it's so powerful because I'm not a great meditator. I do meditate a bit, but meditation is an active process. This is about shutting off thinking and doing.
How important do you think the voice is, choosing the right voice for you?
Big. I'm a big fan of Kamini Desai's voice. I don't know you, Kamini, but thank you. You have a lovely voice. Is
that a guy or a girl?
It's a woman,
Yeah.
Desai. She has a father who also releases these scripts, and I think his name is Amrit Desai. I'm less a fan of his voice. It's a little, whatever. It's just not for me. My sister loves the one, Liam Gillen has a Irish accent that's, quite beautiful to
Calming.
her. Yeah, very calming. And, you just have to find one that works for you. And there are a ton of these on the internet. And if you don't like the intention stuff and there's a company out there called Made For that my friend Pat Dossett and Blake Mykoski started, and they have a free resource that you can find on YouTube, which is, it just says NSDR, non-sleep deep rest. I lump all of these things like hypnosis and yoga nidra into what I call non-sleep deep rest. And the reason I coined that term, NSDR, is that A, I like acronyms because I'm a scientist, and B, I think a lot of people are averse to something called yoga nidra because it sounds like you're going to be doing down dogs or up dogs or chanting or ohms or something. And for some people, that's a barrier to entry, when in fact, the whole, much of the value of Yoga Nidra is simply the self-directed relaxation. Likewise with hypnosis, people think stage hypnosis and you're going to be like clucking like a chicken, whereas there's a well-known and established utility for clinical hypnosis. So non-sleep deep rest is a kind of catch-all term for, tools that you use to deliberately downshift, move the seesaw to the other side. And Made4 has a script on YouTube that's called NSDR, and that's quite nice. It's the voice there is a man's voice. It's my friend Rory Cordial. He has a very calming voice. Yeah.
Okay, so NSDR, non-sleep deep rest. And this kind of brings us back to focus and learning. As I understand it from listening to you a number of times talk about learning and improving our memory and ability to recall and take on new information, there seems to be, and correct me if I'm wrong, two sort of key components. One is the focus, the sort of application side of learning, and then there's the consolidation of that later in these deep sleep-like sort of states or sleep itself. Can you kind of speak to how that all works together?
Yeah, and you're exactly right. Learning is a two-stage process. And the learning I'm referring to is specifically deliberate learning. Children are learning passively all the time. They're taking in new information. Their brain it's not a complete tabula rasa. It's not a complete blank slate. There's some hardwired functions they show up with, thank goodness, like breathing, like heart rate, controlling heart rate.
That helps.
But that helps. Offload as much as you can to the genetic program to hardwire the nervous system so they can learn how to walk. And walking is a good example. A kid learns how to walk and then walks reflexively. But of course, at any stage, you can think about how you're walking. You could do hopscotch, and you have to change your cadence of jumping and walking, right? So that's this flexible transition between voluntary and involuntary movement. But you have to learn how to walk. What we're talking about now is generally deliberate learning, language learning, skill learning, learning knowledge of any kind, learning how to navigate the emotional dynamics of a relationship, anything. Two phases. One is active engagement and focus. Much of the trigger for neuroplasticity as a process is engaged by dopamine and norepinephrine and a molecule called acetylcholine, which is liberated from multiple sources. We always talked about how acetylcholine controls the contraction of muscles, but in the brain, acetylcholine mainly comes from two sets of neurons, one in the brainstem and another in the basal forebrain. And it serves as a kind of a highlighter, marking particular connections or neurons that later stand a chance to become stronger. So let me give an example. I don't speak a second language, but let's say I decide I was going to learn conversational French. I would learn some nouns or some verbs. I would focus on this. And the greater degree of focus that I bring, the greater amount of acetylcholine is released at that time. And at the particular locations in the brain, they're involved in enunciating the words and writing the comprehension, multiple spots within the brain. That kind of marks those or flags those areas as potentially changing later. But the actual rewiring of the nervous system happens during states of deep sleep or sleep-like states. And so when we say neuroplasticity, the brain's ability to change in response to experience, that's a two-part process. It's a process. It's not an event. We always think about things as events, but in biology, almost everything is a process. So the takeaway from this is, in order to learn at any age, the most critical thing is that you bring as much focus and active engagement to the learning, the encoding of the information, bringing in the information, and then that you get into a state of deep rest as quickly as possible. Typically, that would be the night after you learn, after you have this trigger. But there are some beautiful studies published in Cell Reports last year and the year before showing that people who take a 20-minute nap within the 4 hours after these triggering learning, or people that do a non-sleep deep rest type protocol, even just sitting there quietly and not doing anything, they learn much faster. In other words, the brain rewires much faster.
Isn't that interesting?
It's very interesting, and what's happening is very interesting. We've long known that during sleep, there's a replay of the neurons in the same sequence that they were played during the activity in the earlier in that day. Sometimes even backwards for some reason. It's like the song's played backwards at night. Who knows why? I don't think we should focus too much on that right now. But that replay is the consolidation of the information. You learn. This is why you try something physically, try it physically. You can't do it, and then you come back a week later and voila, you can do it. you had the opportunity to change the neural circuits so that now you can do it. These non-sleep deep rest or these shallow naps of 20 to 30 minutes also create a replay or a firing of the neurons. But there's an additional tool. I should say there's a tool which is get as focused as you can, but then relax as deeply as you can.
For how long? Like, if you're going to be focused on something, is there a certain amount of bandwidth we have where it's productive and then it becomes unproductive?
Yeah, and it varies for people, and some people use pharmacology to override what I'm about to say, but generally after about 90 minutes, we exist on these so-called 90-minute ultradian cycles. Everything in sleep is a 90-minute cycle. Everything in waking is a 90-minute cycle. If you sit down to work, you're like, all right, I'm finally doing it. I'm going to turn my phone off. I'm going to write this book. You just wrote a book. So quite nice book, by the way. I enjoyed reading. I'm learning a lot from it. People should read it. Is it out now? This is not a promotional thing like by design. It's good. I learned a lot. I learned a lot of science about nutrition.
Yeah, thank you.
Yeah.
Well, it's meant to be. It's in the ocean. Yeah, it's out in Australia. It'll be out. So
okay, cool.
I think by the time this goes up, ittle be out.
Yeah, I learned a lot of nutritional science. I mean, I as you know, I'm not purely plant-based, but I try and eat like it's.
Yeah. You're doing a great job.
I'm trying. Okay. Your audience can send me some information.
He's doing a great job.
I'm trying.
Trust me.
I'm always trying. So, you read this information, you bring in the information, and then but after you're working on the book and you're like focusing, and of course, people think that the expectation is that you're going to be like a beam of focus for 90 minutes. That's not the case. You can flicker in and out. You're going to get distracted. You bring yourself back. I mean, focus is an active process of bringing that spotlight of attention back. It's always
much easier without the phone. Much
easier using a program called Freedom, free program online where you can just turn off the internet.
Mm-hmm.
It's very painful, as you know, and yet there's something deeply satisfying about completing one of these 90-minute bouts. You really feel good in your brain and body because we were actually designed to do this.
It definitely feels like a grind at some stage.
Oh yeah, and that friction and that anxiety sometimes that we feel is adrenaline. It's supposed to be stressful to learn. It's this idea that we just sit back and learn, or that movies have really destroyed the notion of learning. The idea that you're going to like pick up the sword and suddenly have the skills. Forget it. It's like this doesn't work that way. I mean, it's friction, and some days are good and some days are worse. If you slept better, generally it's better. People are always trying to optimize how much caffeine, background noise, yes music, no music. You have to tweak things according to your circumstances. But after about 90 minutes, you should really take a break and let your mind go idle somewhat. Ideally, you would take a 20-minute nap or a 30-minute nap or do a non-sleep deep rest protocol within the first hour to 4 hours after that. But a lot of us have a lot of demands. You go straight from a 90-minute bout to commuting. Sleep that you get that night is going to be the most powerful tool for wiring the nervous system, right? That's when it really happens. And so we can talk about tools to get into deep sleep and stay asleep more if you like. But there's another thing that you can do, which is that there's a beautiful literature on what's called gap learning effects, where let's say, and this has been looked at for physical skill learning, for music learning, math, etc., where if every couple of minutes, just randomly during your intense learning or focus, you pause and you just take 10 seconds and do nothing. Just let your brain idle, eyes open or eyes closed, doesn't matter. What happens is your rates of learning actually increase. And the reason is, now they've done neuroimaging on this, really excellent studies published in great journals, show that during those little gaps that you're taking, there's a replay of the neurons very fast at something like 10 or 20x the speed that normally they would be rehearsing it. So you're getting more repetitions by stopping every once in a while. Now you actually have to do the work, and how many of these to insert, and it should be random. So there are some free apps out there where you can set like a random buzzer, or just every once in a while you're writing or trying to do something, you just pause and do nothing.
Where was that tool when I was going through school?
Yeah, exactly. And I think that the science on this dates back about 20 years, but it's only now that there's enough of what I call a kind of center of mass around these studies that really point to the fact that gap learning effects are really strong. They're very beneficial. You learn faster. So it's focus, rest. And that can be done on the micro level, like within that 90-minute block. Let's just make up a number for fun so people have something to anchor to. If you're going to sit down and do an hour of work, let's say for every 60 minutes of focus or learning that you try and do, introduce 30 gaps of 10 seconds at random, and truly at random, not on a regular interval. And then sometime later that day, if you can, do an NSDR, non-sleep deep rest. And if you can't, okay, no big deal. You won't learn as fast, but you'll still learn, provided that you get into deep sleep that night. And let's say you have a lousy night's sleep. You'll still learn, but you won't learn as well. And maybe the next night you stand a chance of encoding that information. So neuroplasticity involves a very strong trigger, and then deep relaxation is when the actual rewiring occurs. And there are exceptions to this, but I should just mention, because it brings us back to an earlier point, that when you think about the tools that people use to enhance focus, Ritalin, Adderall, L-tyrosine, excessive amounts of caffeine, nicotine, those all help with the trigger part, but they don't help with the relaxation part. And so a lot of people don't learn. They just get really good at doing, but they don't actually learn. So very effective people, regardless of workplace or activity, sport or cognitive work or otherwise, perform very well because they're very good at regulating the seesaw of focus, relax, focus, relax. And in the long term, it also is very health enhancing as opposed to health depleting. I mean, I know a dozen or more people who have done very, very well in business or academia who are a mess. They're physically a mess, they're emotionally a mess, they're mentally a mess, their relationships are a mess. People that I consider successful are people that are very successful in multiple domains of life. And that almost always correlates with an ability to engage and disengage. Deliberately engage and deliberately disengage.
Yeah, this is reminding me, although a different setting, but a similar concept of work and then relax. Mm-hmm. Back when I was about, I must have been about 19, I had a friend of mine. He's gone on, actually, I haven't seen him in about 10 years. His name is Jake Nicolopoulos. You can look him up. He's gone on to become a professional bodybuilder. Okay. And when I was 19, I think I was like his first training partner, and he was far better than I was at lifting weights, and really I was just there to spot him. And he had this strategy, because he wanted to become a professional bodybuilder from a very early age, of working out, and then he would sleep under his desk after mm-hmm. have a nap during the day. So different setting, but similar sort of concept or strategy there.
Yeah, I think the way to think about it is, that. And thank you, Matthew Walker and others who have emphasized the importance of sleep. Matthew was really kind of first man in on trying to convince the world that this whole idea of you'll sleep when you're dead is really foolish. And listen, I think it's a fact that in order to get good at anything, unless you're just an absolute talent, you need to apply yourself and work hard, and sometimes work longer and harder than you feel like working or is healthy for yourself. I mean, that's a reality. But Matt, I think, really pointed out that sleep is important for learning and a number of other aspects of health. I think that the ability to toggle back and forth between engaged and disengaged states, and to see that whole process, engage and disengage, and the dynamic control of that and deliberate self-control of that is a superpower. And we tend to only look at one side of the equation, the leaning in. I always think the way I like to think of it isn't so much as a seesaw, is you can either be back on your heels, flat-footed, or forward center of mass. I stole this from Pat Dossett, the founder of Made For. He did 9 years in the SEAL teams, and so I like that forward center of mass is great, but it's energetically demanding, and you need to learn how to come up to just flat-footed every once in a while. Now, when you're back on your heels, that's a sign that likely you were doing too much time forward center of mass. No one wants to talk about this, but people who grind rarely succeed and then just take off and do something else. I think humans have mastered this process of engaging and disengaging on a longer time scale. Work hard, play hard, or they'll take a long vacation. But what I'm talking about doing this is across the day. I'm talking about regulating your nervous system within the unit of the day, or even within the unit of the morning, or within the unit of the afternoon. And I think that that's a much more useful, at least to me, a much more useful time bin to conceptualize this. Because the idea that you're going to, sell the company or launch the thing and then you'll rest. Okay, but you can be so much more effective if you know how to dynamically control your nervous system in real time. And great athletes know how to do this. Great musicians know how to do this. Even within the playing of a piece of music or within a race, they know how to reserve energy so that then they can kick at the end. Or in academics, you learn, I was always on the quarter system, which is a 10-week system. You learn how to pace yourself through the quarter, because otherwise you're coming in screeching at the end, and you then get 2 weeks off, and it's really stressful. You're just trying to recover your health, and then you're back into another cycle. So I think one of the reasons that I'm not superb at this, but one of the reasons I've been, at least partially successful in maintaining a laboratory and doing a podcast, and I like to think, you can ask the people in my life, decently effective in my personal life, is that I think all the time, am I pushing too hard? Yes or no. And there are times to go forward center of mass. Don't get me wrong, but this can be done with forward center of mass can be done if you wanted through drinking caffeine. In the supplements that we talked about earlier, or pharmacology we talked about earlier. The main way to do it is to get in that kind of inspired and motivated pursuit. But then physiological size, non-sleep deep rest, reverie, all of that is very useful. But the foundation of that whole process, there's a third layer, which is sleep. When you're well rested, you're able to engage this forward center of mass, flat-footed thing at will much more easily. When sleep suffers, everything suffers. And so I always say, when people come to me and they say, listen, I think I have attention deficit, or I've got anxiety, I always just say, how's your sleep? You want to always start with sleep. Great sleep makes everything better. And then once that's in place, then you can start thinking about some of the other processes.
So you really can't build up a sleep debt that you sort of repay later all in one chunk.
Well, Matt tells us no, and he's the more qualified sleep researcher. I don't really work on sleep per se, although our studies include measures of daytime sleep disturbance and things like that in the studies we're doing now. But Matt's the guy. And there are others out there too. Of course, Stanford has a sleep clinic. And when I talk to them, they tell me no. However, there is an idea that's sort of growing now that if you can't get enough sleep, because many people can't, shift work, new parents, hardworking students, anxiety-ridden folks, or you just have a bad night or noisy outside, something wakes you up. That's where these non-sleep deep rest protocols and naps come in. Can you recover sleep in its purest form? Probably not. But can you do things that offset some of the damage of limited sleep, or maybe place you in a more effective position cognitively and physically? Absolutely. I mean, I've experienced that myself, and I think that the neurochemical signatures of non-sleep deep rest point to the fact that those practices really can help you be in a better position. It's sort of like optimal nutrition is, I daydream about, and I'm sure they're around here, so I just need to work a little harder, getting my fruits and vegetables from a local farm, drinking the cleanest water out of springs. I mean, this would be wonderful, but that's not my daily life. So I try and do what I can that gets me closer to that, but isn't the ideal circumstance. So I think, can you recover sleep debt? Probably not completely. Can you do things to offset it? Absolutely. Is there a little sleep IRS running around that's eventually going to come around for all the sleep you didn't get? No. That's also, I think Matt would agree with me there. So I think the goal should be that 80% of nights you're getting quality, sufficient sleep.
So when you say quality, other than things that we've kind of already gone through, what are some of the things that you consider that you think are instructive for other people to consider, or perhaps you do yourself with your routine? I know you talk about light, for example.
Right.
How can people encourage better sleep?
Right. So great sleep to me is you fall asleep relatively easily. You wake up no more than once. It's actually pretty normal to wake up once in the middle of the night and go use the restroom and go back to sleep.
Good.
Because a lot of people freak out when they wake up and they're like, oh, my sleep's messed up, or their Whoop score, their Aura score is off. And, I don't think it's that big of a deal. I mean, ideally you don't, but, a lot of people have what's called nocturia, which is nighttime need to urinate. So it happens. Couple of things that the path to a really great night's sleep starts in the morning. I've talked about this a lot, but I'll say it again. Wake up. If you want to be alert, get as much bright light in your eyes as you can. Never look at any light that's so bright that it's painful to look at because it can damage the eyes, but ideally sunlight. So if you wake up at 4 a.m. and the sun isn't out, turn on bright lights if you want to be awake. But if the sun is out, once the sun is out, go outside without sunglasses. And yes, you have to go outside. You can't do this through a window or through a car windshield, and get some bright light in your eyes. It doesn't have to be beaming directly at you, but indirectly or in the general direction of the sun is good. Wearing corrective lenses or contacts is fine, even if they have UV filters. That light can get to the neurons in the eye that trigger a whole set of processes. It sets in motion a big increase in cortisol, but it's a healthy increase that leads to alertness. Triggers an increase in body temperature, which is important for waking up. There's a whole set of processes there. And it sets a timer on melatonin release so that about 16 hours later, your melatonin levels are going to go up. How long to view light? Well, anywhere from 10 to 30 minutes, depending on how bright it is. If you wake up and you go outside and it's 9 a.m. and it's beaming bright light and you're on a snowfield, it'd probably take 30 seconds. If you're in the depths of the UK winter and you go outside and there's a lot of cloud cover, maybe 20 minutes. You can check your phone out there. You can do things out. You can take your coffee out there, but you have to get outside. The window filtration is a serious
issue. Do you do that every day?
I do it every day.
Every day.
And I don't get enough sun off my porch behind us. So I will walk up the street. My neighbor's all, there. And I walk up there with my coffee. I often bring my journal and just kind of write down whatever comes to mind. Get some sun in my eyes. My partner and I will walk up there and we'll just chat and then we'll come back. And you do that most days. If you miss a day, no big deal. If you miss 2 days, you're starting to drift. And when I say drift, I mean that these neurochemical systems are going to start to get out of sync with the daylight cycle. Shift workers is a whole other business. We don't have time. I did an episode on shift work. People can find that on our website because it's very particular to shift work and jet lag. But that morning light pulse light viewing is immensely important. A drift in cortisol peak toward the later day is a signature of depression and waking up at 3-4 in the morning and not being able to fall back asleep. Signature of depression.
A drift in cortisol peak. So you'll get that drift if you don't get that light exposure early in the morning.
That's right. And so you're going to get a pulse and a big increase in cortisol at some point every 24 hours. You want that to be early in the day and when you want to be alert. Now, some people wake up at 10 a.m., right? I've got a friend who's, I consider, he's kind of a mentee of mine, and he likes to sleep in, and he's a teenager. He sleeps in. So he's going to wake up at 10, but then he goes outside and he gets his sunlight. If you wake up at 5, again, if the sun isn't out, turn on as many bright lights as possible and then go outside once the sun is out. Why? Because early in the day, you need a lot of bright light in order to trigger this mechanism. Now, the second tool is that later in the day, as the sun is heading down, it doesn't have to just be crossing the horizon. You also want to get light into your eyes for the following reason. It adjusts the sensitivity of what we call the retinal photoreceptors, the cells in the eye that detect light, and makes it such that nighttime light that you're going to get at 8 or 9 p.m. won't have as severe an effect on reducing melatonin. So I consider it kind of your Netflix inoculation. Because when you're viewing screens at night unless you have built your house so that all the lights are red lights and they're really dim, most people use artificial lighting at night, and that can mess up sleep. So if you're really extreme about it, you make your house a cave at night. I don't do that. Okay. I tend to dim the lights. I don't like bright lights after about 7 or 8 p.m. But getting that afternoon light is great because it sends 2 signals to your brain and body about where you are in time, meaning time is the rotation of the earth. So you get your cortisol pulse early, melatonin comes on. People who start waking up late or super early and they spend all their time on their phone, it's not enough light to trigger these mechanisms early in the day. But at night, retinal sensitivity is such that if you are looking at your phone on full screen brightness or you have a lot of artificial lights on, you're going to suppress melatonin and you start disrupting these mechanisms. So bright light early, bright light in the afternoon, minimize bright light exposure in the evening, all colors and flavors of light. It's not just blue light.
This has got to be responsible for a lot of sleep issues.
A ton of sleep issues. A lot of people have written to me. I would say thousands of people have written to me and said, I get morning sunlight every morning as best I can, 10 to 30 minutes, and my sleep issues are resolved. Now, some people do that and their sleep issues are not still resolved. I would say, then you look to how late in the day are they ingesting caffeine? Do they have a kind of rumination issue? Are they eating enough? I mean, one thing that is not commonly discussed is that in order to sleep well, you have to eat enough, not necessarily right before sleep. And nowadays there's a big movement towards don't eat within 2 hours of sleep. And I think it's generally a good idea. Sometimes I obey that, sometimes I don't. But if you don't have enough starch in your system, sorry, low carb keto people, but if you're going to have sleep issues unless you do other things to offset that. Because starches and the whole association with the tryptophan system and the serotonin system are part of the calming system. There's a reason why we reach for certain so-called comfort foods when we're stressed is because they increase the release of serotonin and they blunt cortisol. So if you're just a bag of cortisol and adrenaline, and you're fasting a long period of time, it's very hard to get quality sleep. Now, and I think intermittent fasting is terrific. Sachin Panda, who really is the one that kind of popularized this at the scientific level anyway, is a friend and colleague of mine, does beautiful work. But, you need to figure out how much to eat and when to eat and what to eat in a way that still allows you to transition to sleep. So I would say the light viewing early, the light viewing in the afternoon, avoid bright lights of all colors. Blue blockers are fine if you like them, but it's not just blue light that can mess up these circadian clock systems. Any bright light will do that because of the spectrum of wavelengths of light that the neurons that are responsible for this respond to. So then I would say there are some things to do around sleep. I mean, obviously, if you're experiencing a lot of emotional turmoil, that's a problem. Ideally, you're getting enough movement during the day that you're a little bit tired. I mean, you're supposed to fatigue yourself a little bit each day. You're not supposed to have an excess of energy. I will say that about an hour before your natural bedtime, everyone experiences a kind of peak in alertness. This is something not often discussed. This is from, Chuck Zeisser's lab at Harvard Medical School, has shown that there's this spike in alertness about an hour before your natural sleep time. And the just so story is that this was designed to get you to run around and tidy up and shore up your surroundings for safety. And when I say designed, I'm not referring to, I don't get into issues of I would say one thing is absolutely certain, which is I wasn't consulted at the design phase, and neither were you. So I don't want to get into discussions about religion and whatnot. I know many very religious scientists. I know a lot of atheists too. So that's not what I mean by designed, but arranged. So if you are experiencing a lot of pre-sleep anxiety, just realize that naturally passes after about an hour. And I think that can help a lot of people. And then if you wake up in the middle of the night, Nidra or some other NSDR, some people do very well with supplementation for sleep. And I've been very active in promoting this because I saw a lot of people taking sleeping pills, prescription sleeping pills. And I can't believe that this many people rely on sleeping pills. It's crazy. First of all, drinking alcohol or THC before sleep will get you to sleep in many cases, but the sleep is of very poor quality. That's been established over and over again. And I don't care what people do; it's up to you. But a couple glasses of wine to help you fall asleep, your sleep sucks. Frankly, scientifically speaking, it sucks. And there's a whole set of other issues that you're creating there. Now, the supplements that make a lot of sense scientifically are things like magnesium threonate, THRENATE, or magnesium bisglycinate. Both of those they need a transporter to get from the gut to the brain. And threonate is actually shown to be cognitive enhancing in some studies of age-related cognitive decline. So yes, my podcast has a relationship to a supplement company, but I don't want to mention, just shop for price if you're going to go down that route, because I don't want to make this promotional. Bisglycinate or threonate, a lot of people do very well taking apigenin, APIGENIN, which is a derivative of chamomile.
Is there a dose on the magnesium?
So on the magnesium, they distinguish between elemental magnesium and the standard dose. You want somewhere between 140 and 200 milligrams of magnesium bisglycinate or magnesium threonate. I should say 5% of people that I've heard from who take threonate get severe gastric distress. They get diarrhea, but most people don't. A few people do. One of my podcast employees, he can't take threonate, but he does really well with apigenin. Apigenin is 50 milligrams. Swanson is the only company I know that makes it. I have no relationship to Swanson. Apigenin activates a different system, the GABA system, which tends to turn off thinking. A lot of people do really well just with the magnesium or just with apigenin. I happen to take both. And I confess that a couple of nights a week, I'll take 300 milligrams of GABA or 2 grams of glycine on top of that. And then it's like the sleep of gods. It's really amazing.
So what would be the problem with taking those every night? Is there an issue, or you just choose not to?
I take the magnesium and the apigenin every night. And I occasionally take the GABA and the glycine. The GABA glycine added in tends to create really deep, really long sleep. And oftentimes I don't want to sleep longer than 6-7 hours. But if people are having trouble sleeping, they should certainly do the behavioral things, but then consider 1 to 3 of those supplements. And I again, check with your doctor. People with heart conditions might need to be particularly cautious about magnesium. But if you're not interested in the supplement route, the way I used to do this was to drink a cup of chamomile tea before sleep. And the apigenin in chamomile tea is a number of positive effects, but one of which is to make you feel less anxious and kind of calm down. I don't know how much chamomile tea you have to drink in order to hit that 50 milligram concentration, but there's no reason it has to come from a pill. And I think the magnesium sources, I actually don't know what the actual source of the magnesium is, so people could look into that. But I would just shop for price. These are relatively inexpensive. And considering what an outsized positive effect a good night's sleep has on everything, mental and physical health and performance, seems like a pretty good investment.
Those last two, GABA and glycine. What are the kind of doses?
So for GABA, I'm generally looking to get anywhere from 200 to 300 milligrams. And for glycine, it's 1 to 3 grams. And then for the threonate and or bisglycinate, either I use those interchangeably because they effectively have the same effect. You're looking at about 140 to 200 milligrams. Some people go higher, but then you can feel really drowsy the next day. And then apigenin is 50 milligrams. There are other things out there too. I do not recommend melatonin.
I was going to ask you that.
I do not recommend melatonin for the following reason. One, it's a hormone that has other functions besides helping you fall asleep. It interacts with the reproductive axis, estrogen and testosterone, not necessarily lowering or increasing, but there's a lot of dynamic slow effects in those systems. The other is that the dosages of melatonin that most people take are outrageously high compared to what the pineal spits out on a normal basis. You'll see dosages of like 1 to 12 milligrams. That's a huge amount. I mean, we were talking about weightlifting earlier. This would be typically the male testes, both testes, assuming someone has both testes, will release anywhere from 7 to 15. Do I have this right? Yes, 7 to 15 nanograms per day. And I'm sure someone's going to correct me on that. So correct me. But this would be the equivalent of taking, 100x that in the melatonin system. And of course, there are people that take 100x that in the testosterone system, and they have other issues. But melatonin just shouldn't be taken at excessive dosages, and it helps the transition to sleep, but doesn't help you stay asleep. So I'm not a fan of melatonin, and I haven't run into any problems yet with the melatoninistas coming after me. So I'm assuming that if people have switched over to this cocktail, that it's working for a number of people. Again, the magnesium might be problematic for some people. And then there's one last thing, which is theanine, right? Which is THEANINE. Theanine is actually being packaged into a lot of coffees now and energy drinks secretly because it reduces anxiety. And so they're getting you to drink more coffee and more whatever energy drink by trying to remove the jitters. Some people like theanine about 100 to 300 milligrams before sleep. Sleepwalkers and people who have night terrors don't take it. It makes for very lucid dreams, and very vivid dreams, I should say. Not always lucid, but always vivid.
So would you recommend, if someone's not taking any of these, to introduce them all at once or one by one?
One at a time.
Yeah.
One at a time. I mean, I've learned over the years that bisglycinate or threonate is really the sledgehammer for me, the good sledgehammer. The apigenin gives it a little bit of a different buzz. And sometimes I like to have them all. Like, for instance, last week I flew to Boston for 24 hours to give a talk. And I never sleep well in hotels. I don't like the air. I'm not that finicky, but so I really loaded up on everything in order to enhance my sleep, to make sure I could sleep. But when I'm at home, if I'm really tired, sometimes I'll fall asleep with the pills in my hand. I've had that happen. Like, I'll take those in a few minutes, you sleep through the night. I've never found any dependence on these. Like, if I forget them, I don't have trouble falling asleep. So it's very different than a sleeping pill. And again, I guess I do use a lot of supplements. My take on supplementation is they're just compounds like anything else. And if there's an opportunity to take safe, non-prescription, fairly low-cost compounds as opposed to a prescription, high side effect, potentially addictive or habit-forming compound, why wouldn't I resort to the over-the-counter thing?
So how sometimes people talk about prescription sleep medications, helping people fall asleep, but maybe affecting quality. It's not something I've looked at closely, the actual data on that, but would these supplements, do they just help you fall asleep or would they affect quality at all?
They do affect quality, but in the positive direction. So We've done a lot of work with Whoop in my lab. They've been generously donate. I don't have any financial relationship to them, but they've generously donated Whoop bands for some of our studies. We haven't looked at supplementation specifically, but because of that relationship, a lot of people who use Whoop will just write to me and show me the shifts in their deep sleep, because one of the measures that comes out of the Whoop band is how much deep sleep. And deep sleep is a complicated concept within the scientific community, but you get a score, deep sleep score. And they show very significant improvement. I see a lot of significant improvements in the amount of deep sleep, less nocturnal waking episodes, and so on. I don't want to share names of people that have given me their information or data. And I've received, I would say now I'm in the like upper, nearing 1,000 of people say, wow, like my Whoop scores are so much better. They're so much better. And the Whoop scores are just one readout. The subjective feeling of how alert you are during the day is the most important thing. Insomnia actually has a definition. Insomnia is feeling so tired that you need to fall asleep during the day. A lot of people think they have insomnia, but they don't have insomnia. They have sleep disturbance. Insomnia is a true inability to sleep that invades with daytime productivity, such that you just need to sleep during the day.
Is this related to brain fog? Do you think when people use this sort of term, I mean, firstly, is brain fog a scientific sort of a defined term?
No, great question.
And when people are saying, in the afternoon they're experiencing brain fog, could this be a result of their sleep?
Poor night's sleep will almost always create brain fog, if not the first day, then the second day. Brain fog could be any number of things. It could be lack of adrenaline. Some people are just not engaged enough in what they're doing. It is amazing how we can be so excited and engaged in certain things and not in others, and feel so sleepy in certain environments, and then all of a sudden we're wide awake. I've lectured to many students that feel this way about my material.
I know the feeling.
Yeah.
There's this. I won't go into the details, but there's this office in Sydney, and whenever I walk into this place, I literally feel so tired.
Yeah.
And it might just be the types of conversations that I'm usually having in this setting, and I'm not fully engaged. But something triggers me in that environment where I just feel sleepy.
Well, low oxygen turnover will definitely contribute. Slightly elevated temperature, low oxygen turnover, these kinds of things. I mean, this is the post-lunch lecture phenomenon. I don't lecture undergraduates anymore, but used to look out, and I would teach at night. I actually preferred to teach at night when I was teaching undergraduates, because in the evening people are a little bit more conversational. So I do these nighttime lectures. 6 to 7:30 p.m. And it was great, but there were always a couple of people just dozing. And I was a student that had a hard time staying awake in class. I think being stationary, just listening to the hum of a voice, the temperature's up a little bit, and next thing I know, it's like class is over. Some of the best sleep I ever got was in classes, but please don't sleep in classes if you can avoid it. I think that being actively engaged in material is very key. That I did an episode on ADHD, and one of the things I learned in researching that episode is that people who have ADHD actually have a remarkable ability to focus if they really like the activity, which tells you that the dopamine system, which is associated with really liking and pursuing something, is really key for attention. And no surprise, Ritalin and Adderall mainly work to increase attention and focus by increasing dopamine and adrenaline. So I think if we like a place and we like a topic and we care about it, we tend to be alert for it. And when we're not, we just kind of drift off, which is sort of of course, answer.
Yeah, right. Like it's common sense, but it sounds like the most important part of hacking focus and attention is finding something that you enjoy doing.
That's right. And I would say find something that you really enjoy doing and have a tool so that when you have to engage in things that you don't want to do, you know how to go forward center of mass anyway. Because I'm not saying that people should pursue things in life they hate, but one thing that I did when I was in school, for instance, there were a couple subjects that I really didn't like. And I would try and lie to myself and tell myself that I liked it. But then I decided, well, okay, adrenaline and dopamine are these alertness molecules. And I'm just going to think about how much I hate this topic. And then I'm like, I actively hate this, not bored by it, but how much I actively hate this topic. And then all of a sudden you get this attentional engagement. And I was like, I'm going to defeat this topic just to prove, like, I'm going to wrestle this topic to the ground. And so then I was able to do it because I had to take the course. And then what you find, which is kind of ironic, is then if you do well enough on a particular subject, you're like, I kind of like that topic. It's because you've conquered something. So I think it's good to engage in things and find things that you really enjoy, leverage these dopamine systems. But look, there comes a time and place where you have to lean into effort that you simply did not choose. And that's part of becoming a functional adult, I think. And it's also something that Anna Lemke, when she came on my podcast, discussed. A lot of younger people these days are really focused on finding their passion, and they're waiting for something that engages them so completely that everything seems very facile and they're just able to be forward center of mass all the time. Sometimes you have to enter things through the back door. And in order to feel really excited about something, you have to feel as if you worked through that friction. That's an accomplishment in and of itself.
So what is it from a sort of neurochemical point of view that explains why some people just seem to love that friction? And, I mentioned Ronda Rousey before. So I watched her documentary.
David Goggins.
Yeah, David Goggins,
yeah.
Right? Both great examples of someone who just shows up
yeah.
time after time
yeah.
after time and puts the work in, and what they're doing is hard work,
right?
Right.
Yeah,
but for some reason they have the fortitude, and they, I guess we would probably describe it as discipline. Is there something from a physiological point of view that explains that grit?
Yeah. So just very briefly, the neural circuits for dopamine and reward and pursuit and motivation largely come from two what we call parallel pathways, which we talked about earlier. And the main one is the so-called mesolimbic reward system. This, I throw out the names not because people need to know them, but if they want to look them up. This is a batch of neurons in the brain that release dopamine when we are headed toward a milestone, when we can sense a win. Okay? We can sense a win. It's not, contrary to popular belief, it's not that you get a lot of dopamine when you hit a jackpot. It's when you feel like you're on the threshold of a jackpot. Dopamine is increased by certain drugs, cocaine, amphetamine, nicotine. By going into an ice bath will increase dopamine 2.5x, almost as much as cocaine, but it's a very long-lasting effect without the cardiac issues. So interesting there. That comes from a study in European Journal
probably
of Physiology.
A bit cheaper as well.
Probably a little bit cheaper, and it generally is conducive to more health as opposed to less. Whereas cocaine is the opposite. So, there are behaviors that put us on the threshold of a win, and therefore increase dopamine. But we have what are called top-down mechanisms. Top-down mechanisms are the beauty of what it is to be a human being. The top-down mechanisms I'm referring to are the prefrontal cortex, areas of the brain real estate that sit right behind the forehead. It subdivides into some regions, but it provides input onto areas of the brain that control things like stress and reward and other features that are what we call kind of vegetative, like the more reflexive, more limbic, if you will. Now, there's a certain friction, I actually call this limbic friction, where let's say you don't want to get out of bed in the morning. You just don't. Maybe you're tired, but maybe you're just not motivated, and you force yourself to get up. What you're doing is you're using top-down control to say, the fatigue I feel, I'm going to override that fatigue. And much of what's online is how do you override that fatigue, that lack of motivation? And some people say, well, you got to do it out of love. And then other people say you do it out of anger. And it doesn't matter. These top-down mechanisms are very subjective. If you are going to do it because you really care about the person that you're going to pick up at the airport and you got to get up early, well, that's one mechanism. If you're going to do it because you're a person of your word and you said you were going to be there, you do it. The just do it mantra is top-down control. Okay. Now, just the top-down control is also involved in controlling reflexes, the desire to consume something that isn't good for you. You can resist that desire through top-down control. The more rested you are, generally, the easier it is to engage top-down control. So when I look at people, I don't know Ronda Rousey. I don't know too much of her story, but I do know David a bit. He's been to my lab, and I endorsed his book, and I'm obviously super impressive. David Goggins needs no introduction. Super impressive, and I think one of the many important things that David stands for is the ability to override limbic friction, to convince himself to do it anyway. And there are others that do this. I've talked about this as well. That is top-down control, and what he's done, if I may. I've never actually figured this out conclusively, but I have a strong sense that what he's done is he's somehow gotten very familiar with the narrative of friction, or the experience of friction, and the narrative of overriding friction, and he knows that a win is coming later. And so what happens is if you know that overriding limbic friction is going to create a win down the line, that win could be a sense of accomplishment, that you conquered something in this limbic friction.
So you need to know what that accomplishment looks like.
You need to experience, it helps to know what the win feels like, yes. And what you can do is you can start to thread back that dopamine from the future to the idea, by getting out of bed, I'm already starting to experience the win. You can anticipate the win. Now, there's actually a paper that was just published on this, is a good timing for this question, which is that really points to the fact that delayed gratification is controlled by dopamine. And it's a somewhat complex paper, so I don't want to get into the details, but what it shows is that if you know that by delaying gratification, you are going to, it's worthwhile, you start to achieve that dopamine increase earlier. So delayed gratification is, as it sounds, is, resisting the urge, resisting the chocolate bar, or resisting the staying in bed, or whatever it happens to be. But that itself can start to evoke dopamine release. Now, I'm not David Goggins, obviously. I never will be. But the way he describes his process is a little bit different, I think, than just pure like, oh, I feel great doing it. He talks a lot of times about how it's very, very challenging for him. But when you talk to people who are very good at overriding limbic friction, you start to get the sense that even if it's very challenging for them to do, that they understand the great reward that's going to come later. And I think for a lot of people, the challenge is they haven't experienced, or they can't see the win and experience the win. And so it's very hard for them to override limbic friction. And I'm not talking about limbic friction as this mild little thing. Limbic friction it's like a booming voice throughout your brain and body of stay in bed, sleep is important. I heard on the podcast, sleep is important, stay in bed. And to override that requires an immense amount of what we call willpower, but willpower is top-down control.
It kind of is also going against what was required of us as a species. Like instant gratification in many ways is a survival mechanism, right?
Mm-hmm. Yeah. I mean, if you could get all your sustenance without having to venture out too far, why would you go any further? Now, the forward evolution of culture in our species and individuals has been created by people that were willing to push out further and further. I mean, right now we talk a lot about Elon, right? He's the one that's sort of like, well, why limit yourself to Earth? Which is a cool concept. But this exists in every domain, as you know. Rich Roll, our good friend, anytime we overcome doubt, challenge, internal doubt and challenge, we're engaging these mechanisms. It's a vital part of our individual development.
Would you say it's a skill?
Absolutely. It's a skill, and there's neuroplasticity in this circuit. That's the thing that's often not discussed, is that the ability to focus is enhanced by forcing yourself to focus. The ability to sleep is enhanced by getting better at relaxing and turning off thoughts. And the ability to override limbic friction can only be created one of two ways. One is to increase your overall levels of alertness through dopamine and norepinephrine. That's why people take Adderall and Ritalin, drink caffeine, smoke nicotine in order to get more alert. They're biologically hacking their way into the system. I think it's beautiful when people can psychologically, I always imagine scruffing myself, like you'd scruff an animal, or you'd scruffing myself and forcing myself into it. Because for me, it helps to third person myself. It's very hard as the way the brain is and the way we identify as individuals. I'm not going to refer to myself in the third person. I will not do that. There's a name for that in psychology. I won't mention it in clinical psychiatry.
We had a bit of a joke before.
It starts with an N, yeah. Starts with an N and ends with an M. Anyway, narcissists generally talk about themselves in the third person. It's hilarious, right? Because they think so much of themselves that they talk about themselves in the third person, revealing the micro squishy inner ego of the narcissist. But what I'm talking about is third personing oneself in service to overriding limbic friction. And sometimes we have this narrative that's so closely tied to our immediate state that we have a hard time forcing ourselves into some other mode of action. And so it can be very helpful to take on a view of yourself that's living in anticipation of the future state that you're going to be in, like successfully getting out of bed in the morning. I did this morning. Last night I said, let's my partner, I said, let's go jump in the ocean tomorrow morning. We got up and it was raining, it kind of like the smallest matter.
Very misty today.
And I was like, oh God, it's going to be cold. And then we're driving down there, and I didn't tell her because I didn't want her to know what I was thinking. I hate getting in the ocean when it's cold. I absolutely hate it. But then we got there, and actually the water was just a little bit warmer than the external environment. It was beautiful. We had the best ocean dip in the morning, and then a sauna afterwards, and it was wonderful. I've been feeling great all day as a consequence. But it took a little bit of override. That's a mild recreational example. But I think that if we can start to see these reward systems and top-down control as things that we can modulate in real time, and use it sparingly. I'm not suggesting people do this for everything, right? It can be very exhausting to scruff yourself into the best action all the time. But look, I mean, people who are recovering from addiction, they have to do this. It's a process from morning till night.
How important is tying that to sort of bed down these neural systems, this rewiring you're talking about? How important is tying that to some sense of satisfaction or celebrating? You mentioned sort of achievement earlier.
Yeah.
Is that sort of critical to closing the loop on all that?
So it's very important to experience a win at some point. But one thing that a lot of people misperceive is that we should always celebrate our wins. The dopamine system is very good at predicting wins. And when it can predict a win, if those wins come on a regular basis, you start reducing the amount of dopamine that's released in response to those wins. It seems a little counterintuitive, but the casino owners understand this. The pattern of reinforcement that works best in animals and humans is intermittent random reinforcement. So one thing that you can do, and I suggest to people, is that if you are working hard at something or you're really pushing yourself, sometimes reward yourself, but occasionally delete the reward, because it sets up, there's something called dopamine reward prediction error. Again, we probably don't have time to get into all it's a computational analysis of what keeps things, people and animals motivated to continue to pursue. And random intermittent reinforcement is the optimal schedule.
Have you done an episode on that?
Somewhat. I did an episode on dopamine, sort of a dopamine masterclass. We got into it, but I haven't really boiled it down to a specific protocol. But it would look something like this. You're in your 90-minute learning bout or work bout of any kind. You're doing your little gap learning things. And every once in a while, you look at the clock and go, whoa, I've made it 30 minutes without looking at my phone. You think, okay, that feels pretty good. Other times, you might say, okay, I made it to the 45-minute mark. I'm going to go get myself a nice cup of coffee. So you have a little bit of coffee. Other times you delete the coffee and you keep working. What you're doing is you're effectively taking that goal line and you're catching little micro wins. It's sort of like a video game where you pick up little coins. I'm an old school guy. I don't play video games, but the ones I did play, like you'd pick up coins and
like
give you
Pac-Man.
power. Like Pac-Man, or there was like the Super Mario Brothers thing. I'm truly old and out of it in respect to this, so forgive me. But what you're doing is you're picking up additional lives or points, but occasionally you don't take anything. It keeps you in pursuit.
Keep it guessing.
Let's say another way to do this is I suggest people avoid layering dopamine. You have one dopamine system that fortunately can be activated by a lot of different things. So for instance, I love the feeling of being completely rested, going into the gym or going for a run mid-morning after a cup of coffee, hydrating well, using the bathroom, listening to my favorite music on a sunny day. But that's a lot of things layering in for dopamine. And what happens is that if that becomes your hope and expectation, fine. But if that becomes your requirement for actually having a great run or workout, you're in trouble, because the next time it's not going to be that exciting and you're not going to be that motivated. You actually won't perform as well. So this year, what I've been doing is every third or fourth workout or so, I think kind of randomly, I leave my phone in the car. I don't use any music, and I don't allow myself any kind of pre-workout stimulant. So I have to generate all the force and energy and everything I'm going to do from internal processes. And you might say, well, that's kind of masochistic. Why would you do that? It's supposed to be fun. Well, I'll tell you, the next time when you bring your headphones and you're listening to music, you feel like a god in there. Why? Because you are secreting so much more dopamine, so much more noradrenaline, so much more effective at performance. But then the next time you have to throttle it back. And so I'm excited by all the tools that are out there, all the, there's all this like cognitive enhancement stuff, and people are plugging into every device and they're trying to figure out, do I have white noise in the background or metronomes and all that stuff. But it's good to not layer in too many things. There are other examples of this where are a little more unfortunate. Pornography is a really good example. There's a huge issue now, right? Because pornography is so much more readily available on the internet. Now let's just remove the kind of the moral judgments about it, right? Because that's not what this is about. A scientific discussion about this would say that there's an enormous availability and range of imagery that's very powerful that feeds directly into the dopamine system. And a lot of people, young people who are growing up watching a lot of intense pornography, are suffering from a lot of sexual side effects and struggles with sexual interactions in real life, because those interactions are not as intense as the things that they're seeing. The other thing that's happening, I should just mention, is that I've got colleagues that work on this in psychiatry, that they are wiring their nervous systems to become aroused viewing other people having sex as opposed to them having it. And so they're running into a lot of trouble there. So what's happening is that dopamine levels are so high that real life it's like eating extremely palatable foods that are just blitzing your system, every taste bud, high salt, high sugar, high fat, to the point where it's just, and let's assume delicious. I don't generally like those kinds of foods, and then all of a sudden it's like, here's a bowl of rice or a salad. It's going to taste like garbage to you because you're at first anyway.
That's also got to be sort of trickling over to just social media in general and the dopamine release in response to that versus, say, for example, a real life conversation.
Right. Well, and if you're on social media and you're scrolling and you don't even know why you're scrolling, like you don't even know what you're looking for, your dopamine system has been tapped out and you need to take a break from it. Maybe a couple hours, maybe a couple of days. I think social media is great. I teach science on social media. I see you all the time on social media. You know, there's a lot of great social interaction. There's a lot of opportunity to learn and see things. Some are funny, some are interesting, some are disturbing. But when you're at the point where you're engaging in something and you don't even know what the win is, but you find yourself reflexively engaging in it, your dopamine system is now plummeting. And that's a serious issue. So the other thing is that a picture is worth 1,000 words and a movie is worth 1,000 pictures. Our visual system is so tuned to watch motion and to see movies. So you're seeing movie after movie after movie after movie. What's happening is the context is switching constantly. The human brain has never been confronted with context switching at this rate. You know, television, went from 6 channels to 12 to 200, but this is the first time that you can walk around with your television. You can have it in your car. You can have it on the phone. On the plane. So I use social media and the internet a lot. Unlike email or reading an article online, social media is, you can scroll through 1,000 different or 100 different contexts within 5 minutes. And that's a big override for the brain. And then the rest of the world seems kind of boring. Like, you see people at dinner scrolling their phone. It's because actually the brain wants novelty. It's seeking novelty all the time. These days, I'm turning off my phone in the evenings. I'm on there a little bit, but I'm finding I'm kind of sick of the phone. I think a lot of people are kind of hitting this point where they're like, I'll get on social media for an hour or two a day, but this is getting a little pointless.
Yeah, but you're right. It has its place, but it's nice to be able to connect how you're engaging with it, using it, and your feelings with science, because then all of a sudden you're in control.
Yeah, and I use the phone. I try and not look at my phone for the first hour that I'm up. Usually I only make it about 30 minutes while I go do my walk. I want to download whatever processing I did in sleep and write a few things down. The phone isn't sinister. It's our overuse of it that's sinister. It's like calories aren't bad. It's overindulgence in calories is bad. It's not complicated, but I think that knowing that the dopamine system is what got you started with the phone, but the reason you scroll is not for more dopamine. It's because you're seeking that big dopamine peak. It's subconscious, but that the amount of dopamine that you're getting from any individual post is tiny, 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 tiny. And then it's more about just trying to get back to baseline. So I say, when you, at first, any activity that's fun, you get this huge peak and then a trough, and then it comes back to baseline. But if you engage in that activity too often, the way that the dopamine system is arranged is eventually you're just engaging in that activity to just be okay. You're just fighting for normal. Fighting for neutral, as I call it. And that's addiction. That's compulsive use of something in order to just feel okay. That's not pleasure.
I feel like I'm getting a good idea as to how your day pans out. Well, a little bit anyway. I feel like you wake up, you go to water first where you can, maybe some yoga nidra on certain days. You push coffee or caffeine back 60, 90 minutes at least. You try and get outside and get some light exposure.
Yep.
And maybe to kind of round out this conversation, you mentioned sauna and you mentioned getting in the ocean, and that makes me think about cold therapy. So two things I know that you've spoken extensively about. What is it about taking our body into these extreme but safe sort of temperatures that is beneficial? Why are these tools that you think are interesting?
Yeah, well, first of all, cold exposure. I started off my career studying thermal regulation. That's what I did as an undergrad. And so I have a deep love of that literature. We have a storage of healthy fat in our body called brown fat, which is literally brown under the microscope because it's rich with mitochondria. Think of it as the oil in a candle. It allows you to feel warm in cold temperatures, and it acts as a furnace for your metabolism. It's generally enriched around the clavicles, upper back, and around the heart, a little bit around the liver. It's not the blubbery fat that people generally want to have less of. It's a deep tissue fat. It's really healthy. Children have a lot of it. You tend to lose it over time unless you do cold exposure. Deliberate cold exposure is one way to enrich the amount of brown fat. You get a stronger furnace. And there's some wonderful science on this published recently in Cell Reports Medicine by the first author is Susanna Soberg from Denmark. And it's really amazing work. What they showed is that 11 minutes a week divided up into a couple sessions of 2 to 3 minutes of deliberate cold exposure increases the density of brown fat in adults and allows them to feel more comfortable in cold temperatures when they're just walking around, okay? But also when they put themselves into this deliberate cold, and I'll talk about how cold in a moment, that then they achieve much bigger increases in core resting metabolism, improvements in blood lipid and insulin management profiles. And there's some other positive effects like improved mental resilience. So a lot of positive effects. Really wonderful study done in humans, right? Because we want to distinguish between mouse work and
when you say increased density of brown fat, so that's not to be confused with increased body fat, right?
No, increased density so that the mitochondrial density of the brown. Think about the brown fat as like an oil in a candle that allows it to burn hotter and longer. Yeah. So that's one aspect. The other. So 11 minutes per week. So what does this involve? Well, a lot of people say, okay, do I need to get into an ice bath? No, you need to get uncomfortably cold for 11 minutes a week. That could be done with a cold shower. That could be done by getting into an ice bath. That could be done by getting into the ocean. That could be done by getting into a lake. That could be, it is not important how you get cold. You could even put ice packs on your neck or in your whatever, in your pants.
Just get cold.
People do that.
Uncomfortable.
You get uncomfortably cold. How cold depends. And people always say, I want to give me a number. Well, what's uncomfortable to you is not going to be uncomfortable to me and vice versa. So uncomfortably cold. And then the key thing is that it needs to be safe, right? I mean, you're not going to jump into 30-degree Fahrenheit water. Your heart will stop, right? So you're going to try and get into chilly water that you want to get out, but you can calm yourself and stay in for that period of 2 to 3 minutes. Sometimes you'll be a little colder and other times you'll be a little warmer. So you don't want to obsess about this. There's one study that was done having people submerge themselves in water of about 60 degrees, which is not particularly cold, 60 degrees Fahrenheit, but they did it for 45 minutes. So it could also be being in kind of, when you get into a pool and it's not quite warm enough, it could be that, but you stay in longer. But for 11 minutes, it should be pretty uncomfortable. Like you want to get out. Ideally, I should mention, there's not much science around cold showers for the obvious reason that cold showers are hard to do in a laboratory because then you don't know, are people is their head under? Are they facing it? Are they turning away? Most of these studies have been done with submersion. But the other day when I was in Boston, I woke up and I thought, I really want some cold exposure. It was cold outside, so I just walked around in a t-shirt. I walked to get some food in short sleeves. Everyone looked at me like I was crazy and got 30 minutes of cold exposure just walking to the store. And I Ubered home because it was really cold. The wind chill was pretty bad. Or pretty good, I should say. So I think you get that 11 minutes per week and that sets you up for this effect. And it should be divided across multiple sessions, but it could be Monday, Tuesday, Wednesday, and then you have 4 days off. It could be Monday, Wednesday, Friday. It doesn't really matter.
So don't try and do 11 minutes in one go in an ice bath?
Probably not. I mean, not at first. I mean, some people can do that. Now, there are other reasons to do cold exposure. What happens when you get into cold? A couple things. You vasoconstrict, and there's a rebound vasodilation, so you're getting better perfusion and blood flow. The biggest effect is a big increase, 2.5x increase in dopamine that lasts for several hours. It's a significant increase. You feel mentally clear, you feel alert. It increases metabolism for the reason we discussed before. And then there's the process of getting into this cold water when you didn't want to. And that is overriding limbic friction. That's that top-down control. So you build resilience. And no surprise there, a lot of the screening tools for special operations and other screening tools involve forcing people people deliberately forcing themselves, I should say, to get into cold bodies of water that are really uncomfortable, but not dangerously cold. So there are other effects too. For instance, if you want to enhance fat loss and lipolysis, it does seem like activating shiver is key, because when you shiver, the muscles release a molecule called succinate. Succinate then goes and activates the brown fat, so you get a further increase in metabolism. And there's yet another, and to activate shiver, I stuttered when I said shiver, it almost sounded like I was shivering. One of the best things you can do is get into the cold source, whatever it happens to be. If you don't shiver while you're in there, get out, but don't dry off and just stand there. You'll start to shiver pretty quickly as it starts to evaporate off you.
I heard you also speak about if you're going between hot and cold, if you're after these metabolic benefits, weight loss in particular, to finish in cold. Is that right?
Yeah. So then there's sauna. So sauna or hot shower or hot bath. I mean, there's a variety of different ways to get the heat up. You need to be really careful with heat because the brain can cook, and you need to approach heat gradually. And obviously people who are pregnant or people who have blood pressure issues, this is problematic. But when you get into the heat, your heart starts to beat faster. It's uncomfortable. So I'm a big fan of traditional sauna, wet or dry sauna, but I'm not a big fan of infrared sauna. Most of the time they don't get hot enough. Some do, but a lot of times they don't. And there is a place for infrared light, but it has nothing to do with heat exposure. If there are some ideas about infrared sauna being particularly useful, but really what you want to do is get into uncomfortable but safe heat environment. And you get vessel dilation and capillary dilation. You get better perfusion. You get better at sweating, which is good, actually, to learn how to offload heat. There's a metabolic increase. It's work to cool yourself off metabolic work to cool yourself off when you're in the heat. You get activation of heat shock proteins. Generally, there's a rebound cooling when you get out that can help you transition to sleep. I do think if you're going to do cold exposure, to do it in the early part of the day because it tends to be very stimulating, whereas heat can be done later in the day. Now, let's say you're going to do contrast therapy. So you're going to go cold, heat, cold, heat. Doesn't matter with what you start with. I like to do heat first, then cold. But this morning we were in the ocean, then went to the sauna. Doesn't matter. But if you're going to go back and forth, it's pretty clear that if your goal is metabolic increase, fat loss, etc., then you want to finish with cold. And so you might go cold, heat, cold, and you finish with cold, and then you have to heat yourself up naturally using your own endogenous mechanisms. And that itself has a big metabolic demand.
So that's what you would ideally be doing more in the middle of the day versus right before bed.
Yeah. And if I'm going to do sauna in the evening, then I'll just get in the sauna, get out and kind of cool off, maybe take a warmish shower, cool shower, and then get into bed. No big deal. But I'm not going to do an ice bath right before bed because generally to fall asleep, you need a 1 to 3 degree drop in temperature. And you would say, well, getting in the sauna, I should heat my body up. No, but when you get out, you have a rebound cooling. There's a big misconception about thermal regulation. Let's say maybe we'll save a life or two here. Let's say you're overheating on a really hot day. You've gone for a run and someone's hyperthermic. You would think, put cold, wet towels over their body. Well, your body has a thermostat in the brain called the medial preoptic hypothalamus. If you put a bunch of cold towels on the exterior of your body, it's like putting an ice pack on the thermostat. What happens? You're going to heat up. A lot of people die that way. So the better thing to do is to cool off the palms of your hands, your upper face, and the bottoms of your feet, because those are the portals for heat loss.
That's what you call Palmer cooling.
Palmer cooling.
Right.
Which has its own tools related to exercise. Now, a couple things about the cold that might be useful. If your goal in strength training is hypertrophy or strength, in resistance training, I should say, is hypertrophy or strength, don't do immersion cold therapy, meaning putting your body into any kind of cold environment, very cold environment, within the 4 hours after that training, because you want the inflammation as a stimulus for muscle growth and adaptation. If your goal is to recover quickly, like you're going to race the next day or something, then get right into the cold, or you're going to compete. So it depends on what your goal is. And then turns out from the episode that we did with Craig Heller from Stanford Biology, I learned that one of the limiting factors on athletic performance of all kinds, endurance and strength, is heating up of the muscle tissue, because as it heats up, pyruvate kinase can't do its action of conversion to ATP and this kind of thing. So if you're going to go out for a long run, you want to take a cool shower beforehand or get into the ice bath beforehand, because it will lower your core body temperature and you'll be primed for better performance. And Stanford's running teams do this, and there's some other teams out there that are doing that as well.
Another great tool.
Yeah, it's fun. There's a lot you can do with temperature. I confess I like to end on heat, just because I'm a little bit of a wimp when it comes to this stuff. I like to get cold, get warm, get cold, get warm, and I'm like, all right, listen, I'm not, I'm not particularly high body fat or low body fat, but I'm not trying to lose body fat on a regular basis. I'm just trying to kind of maintain. So if somebody there are a lot of people out there that also have very low body fat, and with the sauna, I think there are many benefits to the sauna. I should mention that the threshold for sauna that kind of emerges from the literature is about 57 minutes per week. You could do that in one session. You'd want to get out every 20 minutes or so. There's also big increases in growth hormone from sauna. Growth hormone is involved in tissue repair and protein synthesis and metabolism, not just for growing muscles, but for remaining healthy in a number of ways. And that's a hormone that definitely is reduced as we age. So getting into a warm environment for 20 minutes and then getting out for a few minutes and cooling off, ice bath or no, or cold environment or no, but just standing next to it and then getting back in, doing that for about 57 minutes a week total, minimum, it can be very effective.
So 11 minutes cold therapy.
Yeah, per week.
Per week,
yeah. And
57 minutes of sauna per week.
Yes, and people ask, well, will hot showers work as well? Maybe, but there just haven't been a lot of studies. People say, well, I don't have access to a sauna, which for many years I didn't. So I empathize with that. There are ways you could do this. I mean, you could use the wrestler's approach, which is pretty masochistic, but you can, wear double hoodie, double sweats and go out for a run that you'll warm up. You got to be careful about hyperthermia, but there are a lot of ways to do this. But I try and get into the sauna for an hour a week total, maybe 2 half-hour sessions. I try and get into the cold 2 or 3 times per week, 2 or 3 minutes per. It's a game changer. I mean, it will make you feel much better. You will metabolize food energy much better. You'll just feel better. You get that big dopamine kick from the cold, and it's powerful.
Yeah, I started doing it a couple of years ago, and I too find sauna helps me sleep. So I definitely use that more at nighttime. I actually converted a chest freezer to an ice plunge. Have you seen people do that?
Yeah, that works really well. I had one of those, and then the folks at the cold plunge were generous to give me a cold plunge. Again, I'm not trying to endorse anything. I think that, but one of the reasons I like the folks at the cold plunge is that their whole stance is it doesn't really matter how you get cold. Obviously, I think they'd probably like people to use cold plunges, but I'm going to be very straightforward about this, that the price point on saunas and cold plunges is pretty high, right? I mean, it's
an investment.
When you get both of those, you're looking at, that or a motorcycle, which spinal cord injury kind of makes me think, sauna, cold plunge would be a better investment. But you're talking, anywhere from, $6,000 to $10,000 for the whole kit of a cold plunge and a sauna. That's a significant investment. A lot of people don't have those resources. So, or they live in places where they can't put them. For years, I lived in apartments. Academics do okay, but we're not starving in the streets. But if you don't have the space for these things, it doesn't matter if you have the finances anyway. So I think that you could adapt, though. Buying $50 of ice can get expensive if you're doing it repeatedly too. So one thing that's good is if you can get a cold bath, cold water bath, followed by a hot shower. That's a great step forward. Or hot shower followed by cold water bath if you really want to prime the metabolism thing. So that's an at-home thing that most people can do. And then now I think there are more sauna cold dunk things, starting to pop up. But I bought a feeding trough a farm feeding trough for a while, and I put cold water and I kept it outside. I didn't use ice. I would make myself sit in that in the morning, and it was dreadful.
So you can improvise.
You can improvise, and I because I think these high cost, high touch tools they're wonderful, but they're high cost, high touch, and
they're not accessible to everyone.
They're not accessible to everyone, and one of my main missions is to try and, as I said, bring the the beauty and utility of biology, but ideally you do that without having to get a second mortgage out in order to get these things.
Well, it's very inspiring, and I'm sure if that young kid is still tuning in that we spoke about at the beginning, I'm sure you've convinced them to go down the path of neuroscience. I think we did it. We covered a lot. There's obviously plenty more that I'd love to cover in the future. So hopefully we get a chance to do this again. But thank you.
No, thanks so much. I had a great time. Great questions. And like I said, I always learn from your posts and from your book. And I love the way that you really ratchet into the science. It's really wonderful and refreshing. And so thank you.
Awesome. Thank you for joining me for this episode and your interest in science-based conversation. I hope you enjoyed it and found the information covered interesting and instructive. If you did and you'd like to show your support for the show, please subscribe to our YouTube channel where you can stay up to date with new episodes and watch them in video format. Yes, the full-length videos. Please also consider subscribing to the show on the Spotify and/or Apple Podcast app, wherever you enjoy listening to podcasts. You can also leave a review on Apple or Spotify. Again, a great way to support the show and make our content more discoverable for others to enjoy and learn from. If you have any comments about the episodes, suggestions for future episodes, including guests you'd like to see on the show, or questions that you'd like to have answered, please leave those in the comments section on YouTube. I myself and my team will take note of these comments when planning future episodes. Finally, the best way to support the show and receive discounts on products we love is by checking out our sponsors at theproof.com/friends. Enjoy your week, stay well, and I look forward to catching you in the next episode.